All right. What's up, everyone? So, for anybody who's new to the channel, my name is William, and this is my wife, Natalie. And the main purpose of this channel is basically to expose the globe Earth lie. So, everybody believes the globe Earth. You know, we were taught about the globe Earth since we were born, and I mainly focus on debunking the globe using physics. In other words, because there's a lot of flat earthers online that basically focus on visible observations as proofs, which is exactly what the globe Earth does. You know, the globe Earth utilizes vision to prove the globe Earth. For example, the horizon. You know, they claim that that's the curvature of the Earth, and it's obviously all has to do with perspective and a limit of vision. Point being is, I focus on debunking the globe Earth using physics, and the top two proofs I'm going to go over right now is can easily be done, and basically everybody can prove them to themselves and basically debunk the globe Earth for themselves. So I'll go over the two main proofs that debunk the globe Earth, and then I'll get into the topic about terminal velocity. So the number one proof that debunks the globe Earth is the fact that the globe Earth requires a belief in a physical downwards acceleration. For example, when I have an object here, like this ball here, and I release it into free fall from being at rest when I'm holding it, the globe Earth, not only do they require this belief of physical downwards acceleration, so basically we can test that that's not the case. So how we test that there is no physical downwards acceleration is with devices like this, for example. So a device like this, which basically has water inside this container and a buoyant object inside of it. Basically, any direction that this moves from being at rest, for example, if it's at rest now and I accelerate in this direction, we can see the buoyant object displaces relative to the direction of acceleration. So if I accelerate in this direction, the ball moves in the direction of acceleration. So this would be considered a simple accelerometer. So again, a simple accelerometer will detect acceleration from being at rest, in any direction. If I go forward, again, if I go back, and even if I accelerate down, it will get pushed down in the direction of acceleration. So let me just show this. So this is what a physical downwards acceleration versus free fall actually looks like. Here it is. So here, the one on the left is free fall. We can see that there is no displacement. There is no reaction of matter in free fall. But then on the right here, when I actually accelerate it, when I physically accelerate this down, again, we see the reorientation of matter. Again, we can see that the ping pong ball gets pushed in the direction of acceleration, just like the accelerometer here, The buoyant object always follows the direction of the force 100% of the time, it detects acceleration, and that's why it's considered an accelerometer. So again, when I actually accelerate a container with water and a buoyant object inside of it, the matter within it, even the solid object, detects the acceleration. The matter displaces relative to the direction of acceleration, and in free fall, that effects of acceleration are not there. They completely vanish. So matter is clearly showing that there is no physical downwards acceleration, because the matter, an accelerometer like this, would detect that acceleration. So, stop sharing this. So what does that mean from a globe Earth? Well, that means that, again, if objects don't accelerate down towards the Earth and it's the Earth that moves up to the object, that would mean from a globe Earth, because up is relative on a ball. If you're standing here, up is that way. If you're standing down here, up is down relative to the people on top. And again, if you're standing on the side, up will be this way. So up will be in every direction away from the center on the ball. So 360 degrees all the way around. that will be considered up on a ball. So if we can prove that objects don't accelerate down towards the Earth, and it's the Earth that moves up towards the object, then from a globe Earth, that wouldn't work, because that would mean that the globe Earth would have to be growing, at 9.8 meters per second squared, well, which is ridiculous. And basically, it would just explode. It wouldn't work. You couldn't conceptualize a globe Earth model knowing that the Earth is moving up and literally pushing up, which just gives us, what we will call gravity. The force we experience here on Earth, right? So proving that there is no physical downwards acceleration and it's actually the Earth that's pushing up, completely debunks the globe Earth from the start, because they require this belief again in gravity and the pulling force of gravity, not only to explain why objects appear to go down, obviously, but they use it to explain orbits about the sun. They use it to explain day and night, in other words, and how basically how airplanes fly level over a curve, and how water bends, and maintain level. So again, they require this belief in order to push their model, in other words. So if you could debunk the fact that there is no pulling force of gravity, then by default you debunk the whole globe Earth model. So again, you falsify the globe Earth by falsifying the claim of physical downwards acceleration. So that's how easy the globe Earth gets debunked. Because again, gravity is not a pulling force. Physical downwards acceleration has never been measured. And again, it's the Earth that's literally pushing up. And how do we know that? Again, a simple accelerometer like this, again, the effects that we see here, again, buoyancy showing us the direction of the force 100% of the time. So if I was to cut the string of the buoyant object in this container, what direction will the ball go? That will show us the direction of the force. That will show us the direction that the pressure is being applied. The reason why water has pressure, is because it's being pushed, So that's what pressure is. So the direction of the pressure of the water will show you the direction that it's moving, in space. So if you were to cut the string, the ball will move up, showing you that the force is up, and that force, that buoyant force pushing the plastic ball up, is only present when connected to the Earth and at rest. Because when something is at rest and connected to the Earth, it's technically experiencing a force. In other words, it's experiencing a constant motion. Because otherwise, if it was accelerating, the weight of the object or the buoyant effect will increase. But what we witness is a constant weight and a constant motion of a buoyant object rising through a fluid, for example. So again, buoyancy, understanding the effects of a container in motion, it's what's going to show you that it's the Earth that's in upwards motion and objects basically that don't accelerate now. That's how simple it is. So let me just go over the number 2 proof real quick, and then I'll get started. So the number 2 proof, again, the globe Earth claim the Earth is a ball, and they claim to have satellites orbiting the Earth. So again, they need to know the radius of orbit. So by default, they need to know the radius of the Earth. So if they're claiming to go around the Earth, they need to know the size, the distances they're traveling. So they do tell us the radius of the Earth is 3,949 miles. So again, based on that claim of the radius of the Earth, there's a curvature calculation we can get. Let me just present this real quick. So again, based on the radius of the Earth, 3,159 miles, using a simple calculation like this, like the Pythagorean theorem, a squared plus b squared equals c squared, we can, use these numbers, again, using the radius right here, and the distance we want to measure over. If we multiply, the radius squared times the distance, the length squared, that will give us, x squared. And once we calculate for x squared, we find the square root of that. Then we'll get a whole number, and all we have to do is subtract the radius from x, and that will give us a curvature drop. Literally that simple. So again, based on the radius, the claim of the globe Earth, the dimensions of the globe Earth, again, they have to claim that water level means curve, and it's curving at this rate by default. So when we put these numbers to the test in the real world, we understand the physics of water when containing at rest. If we were to go to a lake, that was miles across, 3 miles in this case, we understand that the surface of the water when when it's at rest, that the surface is always going to be level. In other words, it's always going to be horizontal, because water doesn't have the physical ability to maintain a shape on the surface. It will always take the shape of the container, but the surface will always be a level plane. So they're trying to tell us that the surface of the lake, it's curving 6 feet in 3 miles. But we understand, again, the physics of water when contained at rest is a physical impossibility for that to happen. Again, the physical measurement of the Earth would also prove that the Earth does not curve, especially at the 8 inches per mile squared that they claim. Because that would mean that in 10 miles, there will be a 66-foot drop, which is completely ridiculous. We understand, again, water doesn't have the ability to maintain shape, and deviate and maintain that deviation, So, again, the physics of water, that it's always level when contained, proves that the globe Earth numbers are impossible, in other words. So that would be the number 2 proof, in my opinion. Number 1 being that there is no gravity. There's no pulling force of gravity. That would be the number 1. And number 2 is the physics of water. And yeah, that is how easy we can debunk the globe Earth. So I guess I can get started with the topic at hand. So what is terminal velocity, right? So before I get into it, I want to go over some basic principles, because I think it's very important to understand differences in speed. For example, when there's 2 objects or 2 cars, for example, moving at a constant rate, and one of those cars starts to decelerate, the differences in speed between the constant car and the one decelerating is always going to be an acceleration in the difference in speed between the 2. Whether one of the cars accelerates or whether one of the cars decelerates, the difference in speed between the 2 cars is always going to be an acceleration. So I want to go ahead and do a little presentation of that, I guess, just to highlight the point, in other words. So it's my first time doing this. I have not rehearsed this presentation. I mean, I've rehearsed it in my head, but I haven't done it in person. So bear with me. So give me 1 second. Okay, here we go. Okay. So what I was saying, that if you have 2 cars going at a constant speed and one of them starts to decelerate, the difference in speed between the 2 is always going to be an acceleration. So, here, because believe it or not, this has to do with terminal velocity. So I want to highlight this first. It's basically highlighting why objects appear to accelerate in free fall first, because that's going to be key to understanding terminal velocity. So again, if we have this line, just going to be for reference, like for markers. So if I have, let's say we have a car here. So I'll do a box with wheels, right? And then we have another car, we'll say here, right? And they're both moving in this direction at 100 miles per hour, right? So as soon as this one here on the right puts the clutch in, for example, and releases the gas, the force that's maintaining that 100 miles per hour, the constant velocity. Once you remove the force and just apply the clutch, in other words, this car is going to start to decelerate, the one in the front, right? So the distance between these 2 cars, we'll say, is only like 10 feet. So it's not that great, right? 10 feet. So as soon as this car in the front starts to decelerate, it's not going to have much time to decelerate, maybe about a second, we'll say. This will be 10 feet, we'll say it was 1 second. So it would only have about, let's say, decelerated to 95 miles an hour. So in 10 feet, it had 1 second to decelerate, which brought it down to 95 miles per hour. So now the difference in speed between 100 miles from the constant, the one behind it, and the 95 miles an hour now is only 5 miles per hour, which means the impact between the car in the back and the car in the front is only going to be 5 miles an hour. Because again, the car in the front didn't have much time to decelerate. Now, if it was further ahead, like right here, for example, again, moving at a constant 100 miles per hour, now it has 2 seconds to decelerate, we'll say, which means it's going to be able to decelerate down to 90 miles an hour, because now I was able to decelerate another 5 miles an hour. So now in this distance, we'll say 20 feet, or from here to here, from the beginning to there, we'll say decelerated to 90 miles per hour, which is a difference in speed of 10 miles an hour from the constant. So the car in the back will now hit it with an impact force of 10 miles per hour. For now, if we went even further, we'll say all the way over here, now it has 4 seconds to decelerate, we'll say that. Again, if it's going 100 miles an hour, with 4 seconds to decelerate, we'll say 4 seconds. At that rate, if 5 seconds, 5 miles per 5 miles per hour loss per second, that would mean it would lose 20 miles per hour, which will be 80 miles per hour before the one in the back hits it. It will go down to which will be a 20 mile an hour difference. So again, the impact force, the further it has time to decelerate, the impact force increases. Because again, it's not that the one in the back is accelerating towards it. It's because the other one's losing momentum, and the difference in speed between the constant and the decelerating car, the difference in speed is always going to be an acceleration. There's always going to be an increase in the impact force, because between the two is always going to be an acceleration. So let me just do it one more time, a little bit different. So again, we have the first car here going at 100 miles an hour. And then we have the other one here. And again, going at 100 miles an hour again. Again, as soon as it starts to decelerate, we'll say when it decelerates to this point, that's a 5 mile an hour difference. So now it's going at 95 miles per hour, which again, it will be a 5 mile per hour difference between the constant and the decelerating car. At again, this point, it will be down at 90 miles per hour. At this point, it'll be at 85. Just doing this kind of fast. And again, at this point, it'll be 80. And we'll do 75. So again, the difference in speed here is 25. The difference in speed here is 20, 15, 10, and 5. Right here is obviously 0. So again, the difference in speed between a decelerating car, which is this one, and the constant, which is this one, it's always going to be an acceleration. So you can interpret this deceleration as the car behind it is accelerating towards the one in the front. You can interpret that it's accelerating at 5 miles per hour, and then 10 miles an hour, and then 15 miles an hour, and it's accelerating towards the one in the front. You could interpret it as that visually, but physically we know that the one in the front is decelerating, and the one in the back remaining its constant speed it's just simply accelerating because of the loss of momentum of the other car. So again, the difference in speed is an acceleration, but that doesn't mean any of the cars are actually accelerating. If one of the cars is decelerating, again, you're going to get the difference in speed. You're going to get the increase in difference in speed between the two. So, okay, so now the same physics apply when we're talking about the upwards motion of the Earth. So this will be the Earth, right? We'll have a tower, right? So I'm going to go ahead and use the 9.8 meters per second deceleration for this one. So in miles per hour, that's 21.9 miles per hour. 9.8 meters per second is 32 feet per second, and in miles per hour, it's 21.9 miles per hour. So another point to highlight is that one of the callers from the last live stream I did made a good point. That when you're traveling, for example, at 100 miles an hour, in a car, there's going to be more resistance if you're traveling at 100 miles an hour than if you're traveling, for example, like at 50 miles an hour. So that means that at 100 miles an hour, because there's more air resistance, or in other words, more resistance because there's more force being applied, there's going to be a faster deceleration rate at 100 miles an hour than you would be at 50 miles an hour, for example. So in other words, you cannot increase the deceleration rate in the second faster than the first second, because again, deceleration is the resistance, and the resistance, increases with the force. And if the force decreases, then the resistance obviously has to also decrease until it reaches zero. And that would mean an object is completely motionless, or, it reaches terminal velocity, which will be a constant velocity, but we'll get into that after. So we'll say the Earth is moving up based on the deceleration rate of 21.9 miles per hour. That, to me, tells me that there is a great resistance of matter, which tells me there's a great force. So it has to be, in my opinion, the Earth is moving upwards at least 1,000 miles an hour. It could be faster, it could be double, could be triple, I don't know. But in my opinion, it's at least 1,000 miles an hour. So that's what we'll go with. So 1, 2, 3. So that's miles per hour. Fuck, I need to rest that. Yeah, that will help. Okay. So this is the Earth moving up at 1,000 miles per hour, in my opinion. So based on the deceleration rate, again, 21.9 miles per hour. Again, that's in a vacuum as well. You gotta take into account that in a vacuum, there's no air resistance, so the deceleration rate's going to be at its maximum. In other words, when you have add air into the equation, like when you do a free fall test, just you're in Earth atmosphere, or somebody skydives, you're not in a vacuum. So the deceleration rate is going to be slower than 9.8 meters per second, in my opinion. It's going to be slower than the 21.9 miles per hour. So we'll go with 21 miles per hour instead of the 21.9 in the first second. So in the first second, when you release an object, in the first second, it decelerates from the 1,000 miles an hour, 21 miles per hour. Now, not only does the deceleration rate decrease with the loss of momentum as well, but the upwards push of the air also slows down the deceleration rate of a free-falling object. Keep that in mind. Again, as the object decelerates, the upwards push of the air also starts to slow down the deceleration rate of a free-falling object. So again, the deceleration rate starts to get slower. So a lot of the person that called, I think, tried to kind of twist that in their head and try to say that, with objects, since we understand that, objects start to decelerate slower, the less resistance there is, an object in free fall should fall at a slower rate as it gets closer to the Earth. So what they're trying to say is that in the first second, for example, here, the deceleration will be 21 miles per hour from the 1,000 miles an hour. And then in the second, what they're claiming is that it resets again to 1,000 miles an hour. And now in the second second, now it has to decelerate slower. We'll say like 19 miles per hour. And then in the third second, it resets back to 1,000 miles an hour. And then it decelerates 17 miles per hour. So again, they're basically not accounting, they're resetting the speed of the deceleration rate from the second to make that claim that, it should fall down slower. Again, they basically didn't understand what they were claiming. But I'm basically going to clear it up. So here, let's see if we saw this. So again, the first second, 21 miles an hour from the 1,000 miles per hour. So in the second, it doesn't reset from the 1,000 miles an hour. So the difference in speed, how much is it? It'll be 900. We don't need to do that. So yeah, the free falling, the difference in speed between the free falling object in the first second and the Earth is 21 miles an hour. There we go. So in the second second, again, because the air is pushing up, slowing down the deceleration rate, the second second, it cannot decelerate at the same rate it did in the first second. So it cannot lose another 21 miles per hour in the second second or more, again, because the resistance is less now in the second second. Not only that, the air is also pushing up, slowing down the deceleration rate. So now we'll say it's at 19 miles per hour. So now the total deceleration rate here, or the difference in speed now, is 21 plus 19. So now in the second second, it's not just 19 miles per hour. The difference in speed is actually 40 miles per hour now. The difference in speed between the free falling object and the Earth. It went from 21 miles an hour to 40 miles an hour. Now, if we go to the third second, again, the deceleration rate decreasing, now we go down to 17 miles per hour, which is in total 57 miles per hour. The difference in speed of the free fall. Now, what this means is that the air is pushing up at this speed now on the free falling object, because the difference in speed between the free falling object now and 3 seconds will be 57 miles an hour, which means the air is actually pushing up now at 57 miles an hour. So that's what's happening when you're decelerating through the air. Since the difference in speed of the free falling object and the Earth is increasing, and the Earth is pushing up the air, in other words, the air is moving up at the same rate as the Earth, the air is literally pushing up on you, or trying to push up on you at these speeds. So if we go down to the 4 seconds, that will be 15 miles per hour loss, because that loss of speed is decreasing. It would be 72 miles per hour, and so on and so on. So again, the difference in speed between the free falling object, again, that's decelerating, will increase, between the Earth and the free falling object. Again, that doesn't mean the Earth is accelerating up to the object. That just means that the object is losing momentum, and the more it loses momentum, again, the more the difference in speed is going to be. The higher the difference in speed, again, there's going to be a measurable acceleration between the free falling object and the Earth again. So here we go. Let me see. So let me go over a couple of videos real quick before I get into the next section about terminal velocity. Let me exit here. Let me go back in here. Stop screen. Okay, so before I get into the terminal velocity, I do want to go over what is terminal velocity. We'll go over the mainstream definition first, and then I'll go over a couple of videos, and then we'll go from there. So we'll share screen again. I shouldn't stop sharing. So here we go. And this is key too. We'll go back to this one. It takes a person about 12 seconds to reach terminal velocity when falling in a belly to earth position. So a skydiver, in other words. It would take them 12 seconds to reach terminal velocity from jumping off the plane. So we'll keep that in mind. But the definition for terminal velocity is terminal velocity is the constant speed of an object reaches when the force of gravity is equal to the force of air resistance. The speed at which an object reaches terminal velocity depends on its shape, mass, and density. For example, a skydiver in a belly to earth position has a terminal velocity of about 120 miles an hour. Keep that in mind. This number, the 120 miles per hour, they have to acknowledge that number, and we'll see. I'm going to go over why. And they basically inverted the physics, in other words. So there's a reason why they say that objects accelerate down at 120 miles an hour, which equals the resistance of the air drag and the downward force of gravity, right? So again, however, if the skydiver pulls in their arms and legs, their cross-section decreases, which increases their terminal velocity to 200 miles per hour. So When an object reaches terminal velocity, it will no longer accelerate and will feel like it's floating on air. So keep that in mind. We'll go back to this if anything. But yeah, so I wanted to go over a couple of videos. So just to show the amount of force that air moving at like 100 miles per hour plus can actually do. In other words, what it actually looks like. Because winds at 100 plus miles per hour are strong. It's a lot of force in just about 100 miles an hour. So I'm gonna go over these videos real quick.
Usually by this time of year, you've seen our storm tracker Jim Cantore being blasted by a hurricane on a coastline somewhere.
Okay, so I'm gonna go over two videos. This is the first one, and then we'll continue.
But that hasn't been the case yet this season. So Jim went indoors to test the raw power of the wind.
I'm inside the Virginia Tech wind tunnel where wind speeds can get as high as 190 miles per hour. We're not going to go that high today, but we're going to demonstrate the power of wind by going through tropical storm, category 1, all the way through 5 winds to see how much force actually builds up on me and how much I can actually take. The strongest winds I've ever stood in, probably between 80 and about 95 miles per hour. After that, without a harness like this, there's no way.
By the way, this, I'm going to highlight this again, but I just wanted to go over it. This is very important. Again, understanding the force of wind traveling at these kinds of speeds, because this is going to be key to understanding a very important point, about how objects no object is ever motionless, in other words, here on Earth, But yeah.
I could stand in the wind. I'm going to be honest with you. I was a little apprehensive at first. I mean, when you start thinking about Cat 5 winds, and then I started envisioning the destruction that they cause, I'm like, I must be on my freaking mind. So here we are now, strong tropical storm force at about 71 miles per hour. We're almost at minimal hurricane. I can feel my skin starting to vibrate. But that was just amazing to me, to watch your skin wave like that. I've never seen anything like it. Here we are at minimal hurricane force. Look what happened.
That's just at 70 miles an hour, winds. So.
All right, I start going for a ride. All right, here we are at 80. I can't lean into it now. Look at my mouth. See what's happening? No. I mean, this is about the strongest that I've ever stood in at about 90 miles per hour. Wow. We're at 100. Nobody is standing at 125 miles an hour. So any reporter.
In other words, at 100 miles an hour winds, you're basically going to get blown by the wind, easily. If it wasn't for that harness, you will be shot to the back of this room, Probably have several bones broken, who knows, but all from wind power, in other words, wind force.
That says that it's not happening. Mike Bettis came here and he got to 133.
And I think we just made the record there.
So that gave me something to shoot for. And I thought I could get there and certainly go past that.
33, 34, 35.
When he passed Mike's record at 133, then that's a category 4.
At 135, it's like you can't really take a breath of air because there's just so much force even on your mouth. I mean, you could tell just by the way my skin was flapping. When we got to 158.6, my ears had just popped. You can't hear anything. I can definitely feel my skin on my neck and my face moving. I thought at any instant, I'm about to go airborne.
We've never had anybody go that fast before. I was nervous watching it. In fact, I was kind of egging the tunnel operator on to do it a little bit quicker so we would be through it faster.
I'm actually shocked that I got to 158.6. I really wanted to go to 175, but they cut me off. We went to Cat 5. Woo! Woo!
Okay, so that was a quick demonstration of how strong, 100 plus mile an hour winds actually are. This next one here I want to go over is basically an indoor skydiving, basically, and they explain how it works. So it's basically a skydiving simulator, and ironically, you guys will see they require the air to be pushed up at 120 miles an hour because that's the amount of force of air that's required to basically simulate free terminal velocity because that's the amount of air that's required to basically be able to levitate someone or push somebody off of the ground, relative to their mass, obviously. Which, here, let me go over this.
I'm inside the SkyVenture wind tunnel in Denver, Colorado, riding the fierce air currents generated by massive 1,200 horsepower fans. I'm getting a crash course in the aerodynamic principles behind every plane and helicopter. My flight instructor,
using Flirt logic, you know, how they can change the polarity of a helium balloon and stuff like that, you know, using a parlor trick. You can basically say that you can change the polarity of objects here, for example, the skydiver, to basically go up, right? Does that mean air pressure is the reason why objects accelerate down in free fall without displacement? Of course not. You know, so again, just because you can levitate an object using air or using, you know, electrostatics or, you know, electricity, that doesn't mean that that's the cause for the physical downwards acceleration without displacement, you know, without any effects of acceleration. So, just want to make that quick point.
is Rusty Lewis.
So this is a pretty sophisticated system. It's not just some fan blowing.
No, it's very sophisticated. There's a lot of thought going into the design of the building to make it what it is, and as efficient as it is, and as fast as it is.
Without wind tunnels, we wouldn't be jetting off on vacations or shuttling astronauts into space. In fact, the wind tunnel helped the Wright brothers create their first plane. But vertical wind tunnels, or VWTs, open a whole new world of aerodynamics. Skydiving in a bottle. It must take some pretty cool physics to pull off this killer joyride.
Okay, so how does this actually work? I know that there's a big giant fan down there, but I don't see it.
Actually, the fan is not on the floor. There's 4 fans, and they're actually positioned at the top of the building.
Oh, up here.
Yes, the way it works is, as you can see where the flight chamber is here, the flying portion of it where the glass is, the wind comes through the flight chamber, goes to the top of the building, and pretty much separates into 2 columns.
Okay.
And that's where it goes through the fans, so it's pretty much sucking the air up.
The key to my flight is a powerful laminar flow, a jet of smooth air to generate maximum lift. It starts with the fans. They suck in outside air, then kick it sideways at around 30 miles an hour. Now the airstream's got to take a hard 90-degree turn, and it's got to do it without creating turbulence, which would reduce the air power. So these turning vanes are aerodynamically designed to bend the airstream smoothly, twisting it downward. More vanes at the bottom twist the airstream again.
Obviously, they designed those airstreams like that so that the air doesn't lose any force. In other words, so it doesn't slow down, you know, so that the air remains constant. Again.
One more turn, and the airstream is rushing towards me. It's still laminar smooth, but not yet fast enough to make me fly. Now the inlet contractor does its work. The tube narrows sharply, squeezing out the air like toothpaste and quadrupling its speed.
Again, I don't know if you guys ever had ever used a water hose and you squeeze the tip, or you put your finger on the tip to increase the pressure of the water hose, right? So that's basically the same physics that is used here, but instead of water, in other words, it's air. So again, the air is coming out at 30 miles an hour, but the exit point is obviously way narrower, probably 4 times as narrow as the rest of the intake or whatever, you know. And reducing the exit, you know, of the air basically increases the pressure. In this case, 4 times. So 30 miles an hour times 4 is 120 miles an hour. So that's how you can multiply 30 mile an hour winds to 120 mile an hour winds and be able to simulate skydiving. Because that's the force required to be able to lift a human, for example, you know, in the belly flop position. Again, this is facts. This is physics. This can be measured, tested, and repeated. The air pushing up at 120 miles an hour is what simulates terminal velocity. Again, because you're technically floating on air. Like the definition we just read. When you reach terminal velocity, in skydiving, it's like you're floating on air, right? Because again, that's what's required for the air to be traveling at, pushing up on you to be able to simulate that.
Blasts up at 120 miles an hour, roaring into the flight chamber and sending me soaring.
The way we measure it and what we say is that the tunnel draws through about 1 million cubic feet of air per minute.
We're talking hurricane force winds blowing straight at me. They have to be that fast to counteract my terminal velocity. That's the speed at which I fall, when the downward pull of gravity equals the upward force of air resistance. For a skydiver free falling,
again, they invert the definition. Again, it's the downward force of gravity it cancels out the drag force of the air, and that's what it. But the reality is what's happening. Actually, I'll just go over it because I'm going to highlight that anyway.
terminal velocity is about 120 miles per hour. And that's just what I'm doing here, endlessly falling, while the upward airflow cancels that out. Now, if I want to go higher or lower, they can vary the wind speed by adjusting the fan power.
It can do just over about 160 miles an hour.
Is that like hurricane speed? I mean,
Pretty much.
Category 5?
When you're flying, it's about the same.
So now we're playing with some more aerodynamics. Make yourself broader, you create more drag or air resistance, and you get more lift. When you reduce your profile, gravity gains the upper hand, and you drop.
Again, when you increase your surface, when you expand your arms, you're increasing your surface area, so the air is able to push up on you more. And that's what, again, they're inverting the drag force of the air, when in reality, it's actually the upwards push of the air. It's not a drag force, it's an upwards force. It's an upwards push, in other words. Because drag force is like when you're in a car and you stick your hand out of the window, you can feel the drag of the air. That will be the drag force. Again, they're interpreting that you're accelerating down and the air is just there, and you're again, it's just you're just flying through it and falling through it, and the air is like basically that's what the air drag would be. But we know the objects don't accelerate down. So again, the interpretation of the air drag force is actually the air pushing up. It's an upwards push. That's the force.
Drop. You gotta get the balance just right for smooth sailing. But when you do, you feel like you've mastered the science of flight.
All right. So again, 120 mile an hour winds was required to simulate terminal velocity. Again, that's going to be key. So let me maximize. So if I go back to the drawing board again, another thing is it takes 12 seconds to reach terminal velocity from when you jump off the airplane, obviously, to reach terminal. It takes 12 seconds, approximately 12 seconds. That's, so again, with the Earth moving up, let's see. It's kind of hard like this. I think I could do this. Okay. 1,000 miles per hour. Again, the Earth moving up at 1,000 miles an hour, right? And we have an object. We'll do 11 markers for 11 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We'll do 12, right? Again, obviously, a skydiver is not going to wait this long to pull the parachute. But again, just for the demonstration, again, we don't even have to here, let me remove the ground, and we'll just say the air. So we'll do the line to do our measurements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We'll do the 12. So again, this is how you reach terminal velocity using the 9.8 meters per second deceleration, which is 21.9 miles per hour deceleration in the first second. And then that deceleration decreases, in the second second and the third second, all the way down to 0. When the deceleration decreases to 0, that's when we reach terminal velocity. And I'm going to explain how that happens. So again, the first second, again, without any air resistance, we know it's 21.9 miles per hour, 9.8 meters per second. We'll go with the first second because that's what was measured. So obviously a skydiver, there's going to be air resistance. So it cannot be that 21.9 miles per hour. We'll say 21 miles an hour because, again, we'll take account of the air now, of some air resistance. So again, in the first second, there's a deceleration of 21 miles per hour. So in other words, the difference in speed of the air, we'll say 1,000 miles per hour. And again, the speed of the Earth doesn't really matter what it is. It could be 1,000, it could be 500, it could be 2,000. We're measuring the difference in speed. That's what we're measuring. So it doesn't matter if the Earth is moving at 1,000 miles an hour and there's a difference in speed of 21 miles an hour, then obviously that leaves us with 979 miles per hour, right? That'll be the difference in speed. But again, we're measuring the deceleration rate, the difference in speed between the two. So in the first second is 21 miles an hour. In the second second, it would be, we'll say 19 miles per hour. It will be a 2 mile per hour per second slower deceleration rate, in the next second than the previous. So that's how we're going to decelerate down to 0. So in the second second, there'll be a 19 mile per hour. 19 mile per hour, which means in the second second, now there's a difference in speed of 40 miles per hour between the skydiver. We'll do a little person here, skydiving, right? Right? Well, we'll do it on this side where I have the arrow. So here's the person skydiving, right? So the difference in speed now in the second second between the skydiver and the Earth and the air pushing up. So now in the second second, the air's pushing up now at 40 miles an hour, right? In the third second, it's a slower deceleration rate, which is, we'll say 17 miles per hour, which means the air is now pushing up at 57 miles per hour. So the air's pushing up at 57 miles per hour, and then the fourth second, it's decreasing. Again, the deceleration is decreasing every second because, again, the air pushing up is also slowing down your deceleration rate. You have to take that into account. So again, in the fourth second, the difference in speed of the air pushing up and the free-falling object is going to be, what was this, 72? No, I need to do math right now on the spot. 72 miles per hour. In 5 seconds, we'll go all the way down to 0. In 5 seconds, we add the 13 mile per hour again. That will mean a difference in speed of 85 miles per hour. 6 seconds, we'll do 11. Again, it's going to be 2 per second. It's 96 mile per hour now. Difference in speed. In 5 seconds, it will be 9 miles per hour, which will be 100 and what is it? 101. Oh shoot, 101. Let me just erase that. I don't want to get too sloppy. So 101 miles per hour in, well, no, I'm going back right here. This was 7 seconds. Shoot. 7 seconds. In 8 seconds, 7 mile per hour deceleration. It'll be 108 miles per hour. Again, 9 seconds. It'll be a 5 mile per hour, which will be a 103 mile per hour. Again, this is the difference in speed that the air is pushing up now between, the air is pushing up on the free-falling object at this increased speed, because that's the difference in speed between the loss of momentum and the air pushing up. Again, it's increasing per second. So again, at 10 seconds is down to 3 miles per hour. So we add that to the now it's at 106 miles per hour, because again, the deceleration rate is decreasing every second until it reaches 0 again. So at 11 seconds, it's 1 mile per hour, which is, I don't even know if I'm doing I did the math wrong right here already. Bear with me. Shit. Here, I did the math wrong here. So bear with me. That's what happens when you have too much on your head. So right here, it's adding 5 miles to this. So it's 100. Oh shit, gotta switch it. Which one was it right here? Which one was I using? Is this one? What's the pen I was using? This one? I think it was this one. Okay, so right here is 113. Oh my God, I don't even have it right. Oh, here it is. It's this one. Okay, so right here is 113 miles per hour. My bad. Right here is 116 miles per hour. And I was kind of going backwards. I was deducting it there. My bad. And then, did I do that over here? Oh my God. Bear with me. Again, this is my first time doing this. And as it is, right here, I was supposed to add 9, not 5. So it was supposed to be 105 here, which is going to change all of these as well. I was wondering why it wasn't adding up. So again, 9 plus 96 is 105. 105. Then plus 7 is 112. Then plus 5 is 117. Then plus 3 is 120. There we go. Then at 11 seconds, it's 121 miles per hour. There we go. And at 12 seconds, it basically reaches terminal velocity at 121 miles per hour. Okay, my bad. I kind of did my math a little wrong there. I added 5 instead of 9 right here. I added 5 instead of 9. But yeah, as you can see, if taking the deceleration rate of again 9.8 meters per second, which is 21 miles per hour, and then decreasing the deceleration rate every second after that, we can reach terminal velocity. Again, the air pushing up, stopping its deceleration, because again, 120 mile an hour winds, is what will be required to be able to stop the deceleration rate of a free falling skydiver. So in other words, what's really happening in free fall, again, the way they try to define that, again, the way they try to define that is terminal velocity is a constant speed with force. When the force of gravity is equal to the force of the air resistance. The fact is, what's happening is the deceleration rate due to inertia. Again, the air is increasing its speed, again, relative to the decelerating free falling object. It becomes great enough to be able to stop the deceleration rate. So the upwards push of the air, in other words, cancels out the deceleration rate due to inertia. So when it reaches terminal velocity, again, the difference in speed between the free falling object and the Earth, in other words, the air pushing up is 120 or around 120 miles an hour. Because again, that's the required speed for the air to be pushing up on a free-falling skydiver to be able to stop its deceleration rate. You know, so again, it's when the resistance of the object, again, due to inertia, is canceled out by the upwards push of the air. That's what's happening, and they basically just inverted that. You know, it's the drag force of the air when the skydiver reaches 120 miles per hour acceleration down. But the fact is, again, is it's the air pushing up at 100 miles an hour, canceling out the object, you know, the skydiver decelerating, canceling out the deceleration rate. You know, it's no longer decelerating when it reaches terminal velocity. You know, and it takes, again, taking account of the deceleration rates and you know, and that deceleration rate decreasing, you'll reach 120 mile an hour difference in around 11, 12 seconds, right? Again, this is not exact numbers. You know, these are not exact numbers, obviously. You have to take the physical actual measurements, but this is how it would work physically, you know. And again, the difference in speed between it's 120 miles an hour, and that's what will cancel out the deceleration due to inertia. You know, the upwards push of the air becomes strong enough, you know, based on the density of an object, to be able to maintain it at a constant velocity. In other words, not decelerating anymore. And again, we understand how much force, you know, air pushing up at 150, you know, miles an hour. So if the Earth was pushing up, so if the Earth was pushing up at 1,000 miles an hour, and the air was also moving at 1,000 miles an hour, that means that it would be physically impossible for any object to ever be considered true motionless, in other words. So nothing in this reality is motionless. You know, the air resistance, again, or in other words, the air pushing up wouldn't allow it. You know, it's just too much force. You know, again, everything reaches terminal velocity. Why? Because everything eventually gets pushed up by the air. Once the difference in speed between the air pushing up and the free-falling object, once that upwards push of the air is great enough to stop the deceleration rate, then again, it's no longer decelerating anymore. Therefore, it cannot ever be motionless at that point. And since everything reaches terminal velocity, that means everything gets pushed up by the air eventually. So nothing can ever be true motionless, you know. So people that try to strawman and try to say that, oh, when you release an object, it's motionless and the Earth comes up to meet it, is fucking retarded. You know, it's crazy. Like, it's just, but it's literally that simple to understand. I know I kind of added the numbers wrong there a couple of times, but again, this is my first time ever doing this. I'm definitely going to be doing this presentation again. I'm going to be making a small 3 to 5 minute video on this. And basically the top 5, you know, maybe top 10 frequently asked questions about the motion of the Earth and what is terminal velocity is going to be one of them. So I'm going to be doing this presentation on a short video, and I'm going to make a playlist. You know, like another one will be, why do objects appear to accelerate in free fall? You know, which also answers, why is there a greater impact force, you know, the higher you drop things, you know. So again, I'm going to be going over these, you know, again and again and again. And again, I'm going to be doing short videos on them as well, you know, make them more concise, you know, more presentable, in other words. But again, this was kind of like a rough draft presentation of my thoughts about what terminal velocity is. And again, it's simply the difference in speed of an object free-falling reaches 120 miles an hour between the free-falling object and the Earth. It's when that happens, especially when we're talking about skydivers, that's when we have terminal velocity. It's not that objects stopped accelerating down. Again, that's what they try to say, is that objects stopped decelerating. That's what terminal velocity actually is. It's objects stopped decelerating, and now they're at a constant rate or a constant velocity. Again, they try to flip that and say that they stopped accelerating, but we know that objects don't accelerate down. So they simply just stopped decelerating. And that's what terminal velocity is. So, and they had to invert the 120 mile an hour winds the upwards push of the air, because that can be replicated and tested and demonstrated. And again, how I used it, to show how you can reach terminal velocity, and again, 120 mile an hour difference from the deceleration gate they give us, in 11 to 12 seconds, and again, just using, again, I'm not a mathematician like that. I'm pretty sure someone else can, again, getting actual measurements, can probably come up with a better formula or a better, deceleration rate than I did. But that will be the physics behind it, of how you reach terminal velocity from a deceleration. Let me go over some of the comments. I know I haven't even checked any of them. So I'll go ahead and do that now. And then I'm going to open up the panel. So if anybody wants to jump on and maybe try to, if you have any questions about what I just said, anything you want to share, let me go ahead and do that now already before copies in. And I'll go ahead and pin it as well. So go ahead and post the. Okay, let me go ahead and try to pin it. I have to go in another. Nice. Okay, screen sharing. It's right here. Message. Cool. Hey, what's up, Nachiketa? Thanks for joining.
How's it going, William?
Natalie,
good to see you guys.
Hello.
Hey.
So what would you like to talk about?
Okay. Well, I'm gonna go to sleep fairly soon, but I just want to stop by and say hello and good to see you guys. And there's a guy who came to my channel named Iron26 or whatever, and he's from Australia, and he was mentioning something about an ice skater. He was mentioning something about an ice skater, and then if something pushes that ice skater on ice, that ice skater decelerates at 4 meters per second squared or something, compared to when objects fall, which is at 9.8 meters per second square. And that was supposedly like a kind of a gotcha question, where I guess that he was saying that the ice skater should be decelerating 10 meters or 12 meters per second square. I didn't really fully comprehend it. Have you ever had to deal with this question?
No, but to me, the ice skater's connected to the earth, so he's experiencing an upwards push. So
that's what I was saying.
Slow down the deceleration. Yeah, that's going to slow down the deceleration rate, definitely.
Right.
I mean, there's
two vectors to talk about, right?
Exactly. But again, if the ice skater is connected to the earth, it's experiencing that upwards force. So it's not gonna be faster than 9.8 meters per second. It's gonna be slower. It's like when an airplane doesn't do like a parabolic free fall, it does like a half free fall. It basically simulates supposedly the moon's gravity, it does 0.6 G or something like that. So it's just simply slowing down the deceleration rate than what it would be at free fall. And that's what that will be my answer to that. Because he's connected to the earth, as the going down the hill in that case.
Okay. So again, I guess he was talking about like RDD, or objects are trying to. I was trying to explain to him that water doesn't have any buoyancy in free fall, but he was explaining it as if what was he saying, that because it's all accelerating downwards together, and that's the reason why there's no buoyancy in water. But I mean, we have to deal with that constantly, right? This is something that they say over and over again.
Exactly. Yeah, again, this the special pleading, obviously, that in free fall is special circumstances that happen that can be recreated or demonstrated. So again, it's just words at the end of the day that people just use, and if they can't practically demonstrate these claims, then it's no different than the globe Earth at the end of the day.
All right. Cool. Well, I guess that's only two things that I kind of wanted to bring up, and just to ask you what your thoughts on how to address those kind of questions, because I'm still trying to navigate on how to, talk about the upward vector with people who are basically well, with gravity, obviously, that's always going to be a problem. But like right now, people who are stationary flat earthers, they got two things that they're talking about, which is RDD and electrostatic. Those are the two things that they're going to fall on constantly, right?
Yeah, definitely. Before you go, did you catch like some of the arguments, I guess, or some of the points that I made about terminal velocity and what my thoughts are regarding that? Did you catch any of that?
No, I just got here because I was finishing up my on my end. So you wanna let me know on what's going on? What are your thoughts on that?
Well, it's a bit long, but
Okay.
well,
I'll have to go and watch it. I'll have to go and watch it.
Yeah, you can go ahead and watch and just, I guess, if you have any thoughts, I would love to hear. I mean, that's why I open up the panel as well for people that were listening, if they want to come on and share their thoughts and maybe progress the conversation.
I would have to listen. I missed it, so I just arrived. So anyway, good to see you guys, and great to see you, and hopefully we'll talk again soon. And I'll say bye for now.
Yeah, definitely. Yeah, thanks for stopping by.
See you.
All right.
Take care.
All right.
Take care.
Bye.
All right. Bye-bye.
Bye.
All right, so let me go over some of the comments. I know I missed a lot during that presentation, so I won't go too far back. Boomy, I am curious how the air pressure builds up if we are moving up through it. Again, the air pressure builds up because the difference in speed of the constant moving up air and the decelerating object is increasing. So that's why the air pressure increases. If we're moving up through it, again, it's because you're decelerating. If you're talking about free fall, I don't know what you mean by that. Yeah, so if you're in free fall, again, the difference in speed between the air pushing up and the free falling object is increasing. So the air pressure is going to increase. So it's going to feel like you're accelerating down through the air, and the air resistance is increasing, but in reality, is you're decelerating through the air, and the air, remaining at a constant it's pushing up as you're decelerating, and again, the difference in speed is increasing from the air pushing up and your deceleration. So again, you're just going to feel like like you're accelerating through it, but it's the air literally moving up at a constant and you're just decelerating through it. So what is the Earth actually moving through? So if you're talking about what's outside of the Earth, that's unknown. So the medium that's outside of the containment of the Earth is completely unknown. I have no clue. The only two mediums we know here are air and water, right? Or gas and liquids, right? So could be one of those two, I don't know what's outside of the Earth or what the medium, would be outside of the Earth. So bodies of water have ripples on their surface. So even if it had ripples on the surface, the body of water as a whole doesn't deviate at 8 inches per mile squared. Those ripples, could be on the surface of the water, all over the surface, but again, that doesn't mean the water is bending and maintaining that bend, at 8 inches per mile squared. The body of water is still level. You could have a level surface, with bumps. That will be the ripples. But as a whole, the water is still level. There's no deviation from one shore to the other. If you go to a lake, even if it has ripples, there's no deviation from one shore to the other, regardless of the distance of the lake. So again, Again, it is level. You're saying here, so not level. It is. You could have a level surface with bumps and indents, because level is not flat. If you're trying to say level's flat, then you're wrong. So you could say that because water has ripples, it's not flat, sure, but it is level. Again, because the deviation in elevation from all the shorelines, it's going to be the same when a lake is contained, regardless of the ripples. The ripples it doesn't matter. The deviation in elevation from all shorelines and any other point in any other shore, regardless of the distance, it's going to be the same. No deviation. Okay, let me see. Oh yeah, 105. That's when I was getting them wrong. I wonder if some of you caught it before I did. I'm pretty sure you guys did. I mean, again, I was kind of doing a little fast towards the end because it's 11 seconds I was going through. I started going backwards in reverse in one of them, and then I obviously added 5 instead of 9 because I've done that. I've done the addition before this presentation. I literally just did the addition just to make sure, if it could reach 120 miles an hour in 11, 12 seconds. And yeah, using the 2 mile an hour loss every second, technically it does, so again, I'll sharpen it up obviously in the future, but 7 seconds is 105. I think you were correcting me here, Lalo Daniels. If you were, thanks for the heads up, but I was just like zoned in the presentation. I wasn't even looking at the comments, but I'm glad you guys caught it if you did. You made a mistake at 7 seconds. Good looking. I'm glad I caught it though. I'm glad I caught it. Let me see, booming. So it's the air being pushed up or the earth is moving through the space we call air. The air is being pushed up. Air cannot go through matter. So again, if the earth is pushing up, the air cannot just stay there hovering and there move through it. If the air is inside the earth, again, air cannot go through walls or matter, in other words. That's why we use solid barriers to maintain air. So the earth, the floor is pretty solid. So the earth, again, pushing up on the air, pushing up, basically, it's going to push up the air because the air is not going to be able to go through the earth. Air is matter. It's something, so the earth is going to push up against it. And if the earth is moving up at 1,000 miles an hour, that means the air is also moving at that speed. But if we're also moving at that same speed with the air, we're not going to feel the air rushing through us at 1,000 until we start decelerating. And again, that's what happens in free fall. The air, we start feeling that air pushing up more and more and more and more and more until it's able to push us up enough to that we don't decelerate anymore. And that's what terminal velocity is. It's the air pushing up, canceling out your deceleration rate, literally. So again, if anybody wants to jump on and talk about this, I would love to hear other people's opinions about this. Because again, I kind of had like a light bulb moment. It was like 2 different occasions. Again, it was the caller from the last stream talking about the deceleration rate having to be less in the second than the first second because there's less resistance. Not only that, the air pushing up on you as well, it's going to slow down the deceleration rate. So it was an understanding of that and understanding that skydiving simulators, require the air to be pushed up at 120 miles an hour. So it was both of those things kind of clicked in my head, and it's just like, it was like a light bulb moment, that I had. And I've been wanting to do this presentation for like a week now, so I'm glad I kind of had the time, to finally do it. Again, it was a little rough with the measurements there, but for sure, when I do the more concise one, it's gonna be much better. So.
Well, you went really far back in the comments.
I know, it's fine.
Well, it's not that far back,
actually. No, yeah, it's crazy how again when you fuck up in one of the seconds, then everything else is gonna be fucked up, and that's how life is. Again, the globe Earth starts from a false premise. It starts from already a wrong calculation. So if we start building off of that wrong calculation, like we've seen right now, the rest are gonna be wrong as well. Again, you have to make sure, that you're correct. Again, you have to make sure, again, when it comes to physics too, especially, we don't want to start from a false foundation, especially when we're talking about cause and effect. We want to understand what's happening and then build off of that. We don't build off of theories. We build off of facts, demonstrable physics. That's how we get to the truth. We don't build off of theories and then build other theories on those theories. That's retarded. Especially we're talking about objective reality. So. Let's see. Oh shit. The motion is the cause of the gradient. Exactly. It's the motion of the earth and inertia. So matter having inertia, again, a resistance to motion, is what creates pressure or air pressure or water pressure. Okay, and you need those two factors. You need the force of the earth, the motion of the earth pushing up, and the resistance to that force. That resistance is what creates the pressure. That's what gives us our buoyant effect as well, and what gives us our weight. It's the resistance to the force. Without that resistance, there is no buoyancy, there is no weight, there is no pressure gradient, there is no density gradient. Everything would just move at the same rate without displacing anything. There will be nothing, no pressure, no weight, no buoyancy. So. Okay.
Like a couple of questions, but that's just on that.
Let me see. Let me read this. I haven't read it, but I'll read it here. Hey, William, doesn't the air just help the skydiver decelerate faster? Meaning, even if there was no air, if there was enough room to reach zero velocity. Yeah, so again, the air doesn't make things decelerate faster. Again, like I showed, the air, because it's pushing the decelerating object up, it's decreasing its deceleration. So like when you use a parachute, for example, you have a wider surface area. Now the air is able to push up more on you if you're connected to the parachute. So it's going to decrease your deceleration rate even more. So you don't need to reach 120 mile an hour winds or difference in speed between the wind and you with a parachute. It's probably at half of that. You probably reach terminal velocity with a parachute, in like 2 seconds. So the difference in speed of the air and the free falling object was probably only like 20 to 40 miles an hour, or around 40 to 60 miles an hour. So again, the air pushing up slows down your deceleration rate, eventually reaching zero, which is terminal velocity, and it's relative to the surface area or the density of an object. So that's what terminal velocity is. Again, it's the deceleration rate that slows down because of the air pushing up, mainly. So let's see. What does this one say? I think there could be a panoramic infinite scroll effect like some of the old websites did. The horizon might be the continually looped in our visual field. Well, the horizon is just an optical phenomenon. The horizon is not a physical thing. It only appears the way it does due to perspective. And your horizon, again, is relative based on your position of the observer. Again, it's not a real physical thing that's actually there, So, again, it has to do with optics at the end of the day. It's the limit of perspective. It's the limit of how far you can see. And the reason why it's called the horizon is because the Earth is a horizontal plane. It's a level plane. So that's why it's a horizon. It's a horizontal limit of perspective, because we're observing over the Earth, which is level, which is horizontal. And that's why it's a horizon. Let me see. I know this. The ice skater is traveling in a horizontal vector, not the vertical. The argument doesn't make any sense. Exactly. Yeah, that's true too. You know, when you're trying to equate something that's connected to the earth to something that's in free fall, then that's comparing oranges to apples. You know, it's a false equivalence from the start. But at the end of the day, yeah. Okay. Okay, Wolfie, all I can say is I don't think the Earth is a ball, and I don't think we're spinning at 1,000 miles an hour, and I don't know if the Earth is stationary or not. I can only go with what I see. So again, if you can only go with what you see, then when we're looking at train tracks, you know, at a distance, they would appear to converge, right? Train tracks. If you ever stand in the middle of train tracks and you look down the train tracks, they're going to appear to converge. So if we're going based on what we can see only, then you're going to get lost because the physical world is different from the visual world. Because again, we have spheres for eyeballs and light enters our eyes, you know, so there's going to be perspective, you know, how we see the world is going to be different from what it actually is. So if we're just using vision alone to try to determine what the earth actually is, you're never going to get to the truth. So again, physical measurements of the earth, you know, it's what's going to show us what the earth actually is. Understanding that water will always displace under conditions of acceleration, you know, solids, liquids, and gas, you know, understanding that it's what's going to show us that the earth is moving up, you know, relative to us. You know, by debunking, by falsifying the claim that objects accelerate down, and also by proving that buoyancy is an effect of a container that's in motion. You know, that motion, you know, creating the pressure within the medium that's pushing the buoyant object, that proves, you know, and shows and can be demonstrated and recreated that buoyancy is an effect of a container that's in motion. And buoyancy showing that the direction of the force. You know, so again, there's two things to understand there that debunk the downwards acceleration, the globe Earth, the stationary flat Earth, and that proves without a shadow of a doubt that the Earth's upwards motion is what's creating the pressure we experience here on Earth. All the pressure gradient, the density gradient, our weight and buoyancy, and all the effects of motion, in other words. Why does the deceleration not show up on the water bottle drop as a change in velocity? It appears like it is stationary. Yeah, because deceleration, the deceleration we experience here on Earth, decelerates all matter without displacing, you know, all matter together. So the globe Earth takes that and twists and says that objects all accelerate down at the same rate in free fall, but in reality, they all decelerate at the same rate in free fall. And that's why you don't see any displacement. Was that your question? That's why it doesn't show any deceleration. Again, the deceleration due to inertia, it's what is shown, you know. The deceleration due to inertia shows that there is no displacement. That means there is no forces acting to decelerate it. It's literally decelerating due to inertia. Because if it was decelerating due to a force, then we would see that displacement. Because a presence of a force will always cause displacement of matter. That's a fact, whether constant, whether accelerating, or whether decelerating using a force. A presence of a force will always cause displacement of matter. The fact that in free fall, there is no displacement of matter, that, you know, shows that everything is decelerating at the same rate due to inertia. You know, not because there was a force decelerating it or accelerating it, in other words. Because we would see displacement in both of those scenarios if that was the case. So again, the deceleration, it is shown, but it's all decelerating at the same rate due to inertia, so it appears stationary because of that. So, do you think that all physicists are in on the round Earth lie? I ask because my brother is a physicist. No, definitely not. So I could have gone into the, you know, mainstream science, you know, as a globe Earth believer, and I would have just believed everything that I was told. So again, the physics are the same pretty much from the globe Earth explanations, but they invert it. So they basically invert reality. They invert the explanation of what gravity actually is, what's happening in free fall, what's happening with terminal velocity. All of these explanations that the globe Earth have, they are just inverting the physics we actually experience.
Yeah, but not again to address the specific question of are all physicists lying? No. They're just regurgitating what they're taught at the end of the day. So
Yeah.
they're not necessarily lying. They believe what they're told, what they're taught, and they're just
Go along to get
parroting.
along.
Yeah.
Pretty much. They just go along to get along. So have we reached the bottom? Okay. Okay, so we're in hour 26. Okay, you show that one. JC23, technically it does not show the change in velocity. The slinky goes from stretched to retracted. Oh, technically it does show the change in velocity. Yeah, you're right. So again, yeah, it does show the lack of force, in other words, the change in velocity again. If there was an acceleration at play, not only will it stay stretched, it would increase the stretch as well, the slinky. But the fact that it shows, a lack of force, in other words, shows the deceleration. So I'll go ahead and highlight that with the slinky for those of you who haven't seen it. So when I glue a ping pong ball to a slinky inside a water bottle, we can see that the buoyant force of the ping pong ball, again, because it's being pushed up by the water, which is being pushed up by the bottle, which is being pushed up by the earth, in other words, creates that buoyant force. And in free fall, we can see the change. We can see that force vanish and technically starts to decelerate down. So here it is. For those of you who haven't seen this, again, when connected to the earth and the ping pong ball glued to the slinky, it stretches the slinky, because a slinky cannot stretch on its own, obviously requires a force. So we can see that there's a force present, an upwards force when connected to the earth. And as soon as I release it into free fall, we can see that change, Now, obviously, not only can we see it, but we can manipulate it, obviously recreate it, in other words. The upwards force is no longer there, and the whole vessel starts to decelerate. And a lot of people say, oh, well, you can't see the earth moving up. Well, from this reference frame, you could see the earth moving up. The house, the whole background is moving up as soon as you release this from this reference frame, But again, vision alone doesn't prove either or. It's matter. It's the reaction of matter, because action, motion is action. And for every action, there's an equal and opposite reaction. So if there's no reaction of matter in free fall, that shows that there is no action. That shows that there's no acceleration. It's literally that simple. So let me see. Do you think chemtrails have anything to do with this? Because I think it might, if what you're saying is true. What do you mean if chemtrails have anything to do with this? Like, anything to do with what? Like the globe Earth lie, I think. I think chemtrails have something to do with like maybe controlling people in a way, where I think breathing in whatever the hell they're spraying is obviously not good for you. So it's like, in my opinion, it's kind of like when they put fluoride in water, at the end of the day, it's kind of like to make you sick. It's just to fog your mind, in other words, So whatever they're spraying in the sky, again, it obviously can't be good to breathe, but at the same time, too, they say it's like cloud seeding, right? To make it rain, to manipulate the weather at the end of the day. So, what are chemtrails at the end of the day? What's the purpose of them? Obviously, I don't know. I mean, it could be cloud seeding, it could be obviously manipulating the weather. That's kind of obvious, obviously. But at the same time, I don't think it's obviously good to breathe, because at the end of the day, all of those particles eventually, fall down. And at the end of the day, I don't think it's good for us. We should be breathing pure oxygen, obviously. And oxygen you can't see it, So if we can see our air, then obviously that's not air. It's something else. It's like smoke or whatever. But yeah. Mm. At JC23 from Iron, just like you have a belief that objects slow down at a rate of 9.8 meters per second unaided, it is the flip side of the same coin.
So that's in response to JC asking him, so you have a belief that inanimate matter can force itself to move, because he was on with the deceleration question.
Right.
And he said that he agrees that there's no force present in an object in free fall. So JC responds, so you have a belief that inanimate matter can force itself to move.
Yeah, well, it's not a belief that objects slow down at a rate of 9.8 meters per second, at least in the first second. I wouldn't say that they slow down at 9.8 meters per second squared, because I think that's made up. They do that to fit their model. They claim that it's an acceleration, so they say it's 9.8 meters per second squared, but they never measure anything more than 1 second in free fall in a vacuum. So to claim that, is a complete lie, in my opinion. It's not true, so maybe they did measure the 9.8 meters per second, in 1 second, which again, using that number in miles per hour, 21.9 miles per hour, using their number, that measurement, that I don't deny in the first second, using that number and decreasing the deceleration rate by 2 miles an hour, for example, little by little, it will take around 11 to 12 seconds to reach a difference of speed of 120 miles an hour between the skydiver and the upwards pushing air, which ironically it's what's required to reach terminal velocity, right? So I don't think it's a coincidence, in my opinion. So if you think it is a coincidence and you think I'm wrong, obviously I was wrong in some of the math I was doing, but I corrected it. But if you think the physics is wrong about what terminal velocity actually is, then again, you can jump on the panel right now and share your thoughts.
And if you didn't catch it, William did break it down earlier in the live stream, so you could just rewind it and go back.
Oh, the rising Earth, what they're trying to hide with the chemtrails? No, I don't think that has anything to do with hiding unless it's to fog people's mind, just to dumb people down, then I guess you can correlate it like that to the upwards motion of the Earth, because in my opinion, that is the biggest lie on Earth. The fact that people believe objects accelerate down towards a stationary Earth, and it's not the Earth moving up to the object. That, in my opinion, is the biggest lie on Earth. So any distractions on the mainstream, anything, in my opinion, is to hide that fact. It's to defend their belief in the pulling force of gravity. So yeah, everything is a distraction from that, in my opinion. Then you can have terminal velocity.
I don't know if that's a reply to you or if it's in response to JC.
Okay, I need to see. Okay, let me go to this one first. Who said the deceleration rate is unaided? That might be what you picked up from Notch, but he even told you that he's still developing his ability to articulate this topic. Exactly. Okay. Oh yeah. Then you can have terminal velocity. So again, I went over terminal velocity, kind of in the beginning of the video, and I went down, literally step by step. Again, I kind of corrected my math a little bit halfway through because I had it wrong, but I did correct it. But again, it's all there. You guys can check it out.
Here for that part.
Yeah, I don't think you were. But again, it's not the first time that I'm going to be presenting that. Again, that was my first time ever actually presenting it, other than just having it in my head. So again, it was a bit rough, I know, but again, I'll definitely be cleaning it up. And yeah, I think again, I'm trying to find flaws with it, and again, because I don't have a bias. It's just things come to me, things make sense, and if they do, then I present them. I present them how they come to me and how they make sense to me. And again, I would love to hear someone else's opinion about it, if they agree with it, disagree with it, if it sparked any thought in you. Maybe you had a light bulb moment like I did. So yeah. It's more weather manipulation. They even made it a law against it in Florida now. They even made a law. So they're not spraying in Florida, is what you're saying anymore then, right? I guess that's cool. That's cool. Alrighty. So now we're in 36 minutes. So I'm going to go over something somebody sent me in an email like almost 2 months ago. I kind of didn't even want to go over it, but I guess while we're waiting for a bit longer, see if anybody else joins or if anybody else has any questions or any points about what I presented here. We'll wait on that. But until then, I'm going to go ahead and go over this. They sent me two pictures, I guess. It has to do with the salt and egg experiment. I'm pretty sure you guys seen it, This person, he wanted to remain anonymous, which is fine. I'll just go over what he sent me. But he was kind of bugging me at one point. He emailed me like 3 times, and I just obviously, I don't even think it's that important because, again, it's just they're trying to prove RDD, but again, they're jumping ahead. They think RDD causes itself, and it's just the medium. They're obfuscating the fact that it's only present when connected to the Earth, that effect, of density and buoyancy, But we'll go over it real quick, I guess, to see if anybody else joins. Again, this is opportunity for all the trolls as well, that want to expose me, that, that say that I hide their comments.
Or people that feel like they're not being heard or just being attacked. If you really feel like that, anything that's what's going to happen, you'll have evidence if you came on.
Yeah, if you come on, it's live, and if you say that, upward rising Earth, there's always attack me, and they're always rude, and all of this, then go ahead and come on and show that upward rising Earths are unreasonable. Show that I'm unreasonable. Come up and have a conversation with me and expose me, if that's what you think. So.
Just to present your position.
Pretty much.
Give your opinion.
Exactly. So we'll start with, these were the images, so let me see. So again, to this person, this proves RDD apparently. So we'll just go over it real quick. So again, they try to use a false equivalence here to start, but we'll go along with it. So the battery causes the bulb to light, the effect. So the light, the light bulb is the effect, the light, when it's on. The range/intensity of the effect can be varied by altering the thickness of the wire. So you can alter the effect by altering the thickness of the wire, right? Make it brighter, less bright, whatever. So now they're trying to talk about this. The motion of the glass, salt water, and egg causes the egg to be at a certain vertical height in respect to how low it can be in the container. Again, only when connected to the Earth. Again, RDD. The effect. Exactly, it's an effect that's only present when connected to the Earth. The buoyant effect. The range/intensity of the effect can be varied by altering the density of the salt solution. Again, yeah, you can manipulate the water by making it more dense, and that will eventually push up the egg, which is going to be less dense, but that only is a factor under presence of a force. So all of that are effects. So they're not talking about what causes that. Again, altering the medium, sure, can change the position of the egg because it's under the presence of a force. If you were in a free fall, for example, or in a place with no force acting on you, and you change the density of the water, nothing's going to happen. the egg's not gonna start to float, So that would prove that density of the water alone does not cause the motion of the egg. That simple, so that off the bat, this experiment already falls apart, because again, you would have to believe that that's the case all the time, even in free fall, but we know that that's not the case in free fall. In free fall, there is no buoyancy, there is no density gradient, that would cause this egg to be pushed up. So again, let's finish this by altering the density of the salt solution. So let's go to the second one. It's two different ones. So the wires are not needed to make the bulb light the effect. The bulb can be directly connected to the battery, the cause. Okay. The salt water is not needed for the egg to be at a certain vertical height in respect to how low it can be in the container. The effect, the egg can be put in a glass of pure water or even air, mercury, or vacuum. Okay, I don't know what exactly this means. The salt water is not needed for the egg to be at a certain vertical height in respect to how low it can be in the container. The effect, the egg can be put in a glass of water or a vacuum. Again, all of these, changing the medium that surrounds it, altering the egg's position, it's only a factor under the presence of a force, or in other words, when connected to the earth. So again, you don't have RDD without a force, in other words, without motion. So to claim that density alone creates the vector we experience here on Earth, but that vector vanishes in free fall, it's completely, it's just bullshit at the end of the day, cannot be recreated or demonstrated, so yeah, that's something that I guess somebody emailed me, over a month ago, and I guess, I'm sure most of you already seen that. So, we understand, most of us here understand how, RDD vanishes in free fall and cannot be a cause of itself. Otherwise, it will still remain in free fall. That motion vector will still be there in free fall of density and buoyancy, through water, for example. So let me see. Okay, right here. You are so mean, level head. What do you mean?
I think when you were calling people, like they could come on to expose you or whatever.
Oh, that was mean, or you being sarcastic, right?
Well, what else did you say? Like they could call you out, or if they feel like they're being mean. If people are being mean to them, this is their chance or something.
Oh, right.
Yeah,
Apparently,
that
I'm being
was mean though.
I think maybe they were being sarcastic.
Right.
Because obviously, people saying that we're rude and stuff like that, and that was not rude. I'm not rude.
Nobody's
really rude that's representing this topic online that I know of.
If you mean when they respond to trolls, a little. I mean, it's again because trolls don't know when to stop.
Right. Okay, let me see this. Lalo. What you say makes more sense to me, but I am still unsure because my bro is very smart and I remember him studying very hard when we were growing up, so I also don't want to discount him either. Again,
it's a little biased there.
Well, it's kind of an appeal, to authority in a way, because your brother obviously has a more higher, academia than you, I would say, or higher, what would be the word?
A higher level of education.
There we go. A higher level of education that, that's basically where you'll be appealing to. But again,
an appeal or just having a bias because, you've seen your brother
study. I always say that's a personal problem there that you're going to have to get over. And it comes down to where you're going to believe your brother in theories, or are you going to go with...
That's what I was going to say. Are you going to believe what you can practically demonstrate, or just what someone's word explanation?
Yeah. So are you going to accept reality for what it is, in other words, or are you just going to believe an explanation? So This person. Yeah, obviously, I'm assuming you're being sarcastic here, obviously. Don't worry about it, Lalo. Just let your brother think for you. He sounds very smart. Obviously, that's not the way to go. You should obviously think for yourself. And obviously, having that kind of mentality is not good. That's the mentality that most people have. And that's why they push these figures like Albert Einstein and Isaac Newton. And even nowadays, Brian Cox and Neil deGrasse Tyson, they push these characters as some kind of superior intelligent beings, so that people have that kind of mentality that you kind of have towards your brother. Again, I'm not calling you out or anything. I'm just saying that like having that kind of mentality obviously is one way that they were able to manipulate people, is by making people think that other people are smarter than them. Again, just because people can be experts in a certain field, that doesn't mean that they have more common sense than you. Because again, common sense is in the name. It's common sense, meaning everybody has it. Everybody should be able to understand something if it's true. So again, it would literally just require your will. And that's one thing they took from people. It's their own will, their own ability to think for themselves. So now people are just looking for others, to think for them, which is literally cult-like, in my opinion. Cult members, don't really think for themselves. They just look up to their leader or to somebody else that's in a higher position, because again, at the end of the day, cults are hierarchies. They're hierarchy structures, of authority. And that's exactly what we're living. Not just your brother, but anybody in academia that graduates, bachelor's degree, master's degree, you're just climbing up the ladder of this hierarchy. That's all it is. We live in a hierarchy. We live in a cult where only those that are obedient and go with the flow are going to get rewarded. And those that don't are going to be left behind.
And again, I would argue that you're not really learning anything per se. It's more of a memorization game at that point. You're just reading the literature, memorizing it to take your exam, and you either pass or fail. It's not really anything that you're, again, learning per se, but it's just regurgitation. How well can you regurgitate it? And if you regurgitate it to our standards, then you get to move on, or you get whatever degree that you're looking for.
Exactly. So they removed common sense from like the field of intelligence, and especially in schools, and they replaced it with memorization. So they replaced common sense with memorization, and now people just memorizing things and being able to show that in a test that you memorize the answers, that's passed off as intelligence now.
Yeah, you're smart.
Now you're smart. So obedience is being passed off as intelligence, in other words. So think about that. That's how schools have us. And that's why, if you think about the structure of schools, of how they have bells, keeping everybody, on check, go from classroom to classroom, just literally obeying every bell, that tells you to go here, to go there, asking for permission to do anything, go to the restrooms. It's all there to literally just start conditioning you to be in control.
Don't speak until you're called upon. So you raise your hand.
Exactly. So it's literally grooming you, to respect authority over your own common sense.
To ditch your discernment and
Exactly.
trust the others that are in higher authority.
Exactly. Again, part of the hierarchy structures, part of a cult. This is how cults are. It's the definition of a cult.
Just take this information and do what I say.
Exactly. And you're ostracized if you don't go along.
Yeah, if you question it, then you're gonna go further down the hierarchy until eventually
you're gonna be at at the lowest
you're
point,
dismissed.
and the cult will start to go against you. In other words, so let me see.
And we know people are very impressionable. So if a few people start telling you something that the opposite of what you said, you're gonna start to change your logic.
I did say that what you say makes more sense, but I am trying to keep an open mind to the possibility that you might be wrong. Again, I get it. If you're new to this, I can see how obviously jumping into a topic and claiming it as true without actually understanding it for yourself, I would say is wrong. So if you don't comprehend this topic, yeah, but it makes more sense. Obviously, don't just believe it. You know, at the end of the day, that's what we don't want to do. That's what we just got out of, just believing something. Again, if you don't understand it fully, then it's okay. You know, it's okay to.
And I just want to add that it's not about William's not presenting his own idea or his own opinion here. He's presenting demonstrable reality, objective reality. So again, these are things you can do yourself. All the demonstrations he's done, you can recreate yourself. And, so it's not necessarily about, William, well, you might be wrong. So I want to keep an open mind because you might be wrong. But William isn't presenting his own idea. He's just presenting what we can demonstrably demonstrate
and replicate
practically.
Exactly. Yeah, it's not that common anymore. No, common sense is not that common anymore. And again, that's what schools are doing. They're making you replace your common sense, as because that's what makes you intelligent. At the end of the day, that's what makes animals intelligent. And that's the basis of intelligence. It's trusting your own common sense and your own discernment. If you don't have that, then you're not intelligent. At the end of the day,
Common sense is like almost diminishing too, because there's so many different ways to come to lead to one thing.
Mm-hmm.
Yet you have to do it their way, show the work to prove that you did it their way.
Mm-hmm.
Opposed to like, well, there's so many different ways I could come up with this answer, but
yes.
you just want me to answer it specifically this way.
Yes.
So you can't even use your own common sense. It's do it how I said to do it.
Exactly.
So
kind of reminds me of how back then they used to make you, when you defined a word, like the definition, they'll make you define it using your own words, right?
Yeah.
Nowadays, it's that kind of ties to like how mathematics, they want you to do their equation, because if you start doing your own equation, that's wrong. They want you to do it there, but that contradicts the fact that like the definition when coming up with your own definition.
I don't think they do that. I mean, I know they did that when we were in.
Yeah, no, I don't think they do that anymore.
Yeah. But I don't think they do that anymore. I'm pretty sure kids are just using Google to Google all the answers.
Definitely, that's true.
They're having AI write their essays. So there's not. So common sense is even becoming more rare. Discernment is like they're not even using their mind in a way, like
because they're relying on AI. Yeah. The more you rely on AI, the less you're gonna use your own mind. So it's like again, the brain. It's kind of like a muscle. Again, if you don't use it, you're gonna lose it. It's like, again. So if you don't use your mind, you just rely on AI or Google or an authority to give you all the answers, then you're basically gonna get dumber and dumber and dumber. Not thinking for yourself. Again, you don't use your mind, you're gonna lose it. And most people have lost their mind.
And it sucks that they steal your mind. You're not even using it freely because they immediately put you in school at between 4 and 5 and just stunt your growth, stunt your creativity, stunt your free thinking, because we have all the answers and this is what it is. Now learn it. And, again, it steals your mind in a way.
Mm-hmm.
Doesn't even let a child be a child and, get creative. And there was like this thing where people were calling it shifting or whatever, when in reality they're calling it like this thing that they're able to tap into and they're able to create this like place in their head. And I'm like, are they talking about using their imagination?
Right.
So they think they came up with something, like they're just using their imagination.
It just shows that they never used it.
Yes, and the sad part is a lot of them were like young adults or,
I was gonna say, were they in their teens, like late teens?
Yeah.
So in their late teens, they're discovering their imagination. In other words, like when they should have done that when they were 5.
It this something like this is trend where it's like can you shift? Can you tap into that? Because I'm pretending that I'm like Super Mario right now, and I'm like you're doing all these, and it's just like you're just using your imagination, and it sucks that you're doing it this late in life.
Right.
Because again, when you're put right into school, like you're just focused on your schoolwork, your homework, learning how to read.
You don't have time to develop your own mind. In other words. They don't, and when you're out of school, entertainment, and just other drama, your parents not having enough time to spend with you because they're always
that's
working,
another-
So again, the whole system is catered so that you don't develop your mind, and not only that, the fact that they're teaching us a bunch of bullshit in school, not only that, literally flipping, inverting our reality, shows that there is a huge, huge manipulation going on, Again, we live in a cult, and that's what cults do at the end of the day. The cult members don't know what's really going on. They're just blindly following the leader. And that's exactly what we're experiencing. What are your thoughts on the faster than G falling demonstrations? Faster than G falling demonstrations? I haven't seen those. What are your thoughts on it? Can you elaborate? Like, what did they drop, or what does that mean that it falls? Oh, are you talking about execrates demonstrations? Are you talking about execrates demonstrations, JC? Let me see if you.
If not, you could send the links on Discord as well.
All right, I'll wait for your response if that's what you were talking about. Okay, yeah. Oh yeah, they were actually really good. Yeah, fucking execrate, man. Like, trips me out, Andrew. Like, he's on it. Like, it trips me out. Like, oh shit. Like, he's actually thinking about it. Playing with his reality. Well, with their reality, it's everybody's reality, right? And yeah, they were really, really good. It obviously shows the faster, than G deceleration, right? It's actually, because the plane's still connected to the Earth, which is giving that upwards push, which is obviously, tilting faster than G, right? Obviously, it's not free fall. It's actually, being pushed down in a way, and that's why, it falls at a faster rate than the heavier object, right?
Correct me if I'm wrong. Andrew's an engineer, right?
Yeah.
Would make sense.
Physicist, engineer.
Really good demonstrations.
Oh yeah, they were really good, really good. Now, Kevin, do you have a video called Two Density and Buoyancy Experiments? Oh yeah, yeah. You have it, and the last one you show the steel ball falling through the water while free falling is just the way you turned it.
So you have two density and buoyancy experience. The second, I guess, because you showed two different ones. The second one shows the steel ball falling through the water while free falling. It's just this. Is this just the way you turned it?
Oh, okay. So let me show that. I have the GIF here, so I'll show what's happening there. Yeah, I know what you're talking about, and yeah, I knew people were gonna have questions about that, and it's very easy. So what's happening there is, let me just show. I guess I could just show that one by itself, which is
One of those.
I think it's this one. Oh no, it has to be free fall. Yeah, because this is the acceleration
that's
down.
The bungee.
Yeah, it has to be free fall. It's this one down here. Yeah, here it is. So what's happening here is this is the one you're talking about, right? So in free fall, obviously we see that the air bubble, when connected to the Earth, we can see the trajectory of the air bubble going up. We can even see the bottom of the bubble right here be flattened. And then it looks like a bullet shape, but it's flattened from the bottom because that's the direction it's being pushed from. But again, in free fall, obviously we see that the air bubble just turns into a sphere, showing that there's no force acting on it because it's not being pushed up or down. But the steel ball does appear to still be moving down, right? But the reason why the steel ball is moving through the water in this case, while it's all being decelerated, is because the steel ball started to decelerate first before I released the container. So if you pay attention, when I turned it upside down, because I did turn it to basically invert the steel ball, but as soon as I turned it right side up, the steel ball started to decelerate before I released it into free fall. So in other words, the steel ball has a faster deceleration rate than the entire container, which is why it still appears to be moving through the medium. but it's not because it's moving through the medium. It's because it has a faster deceleration rate than the rest of the container. Now, if I had this steel ball being held with a string in a hole from the top in water, and I released everything at the same time, the steel ball and the container, the steel ball is not gonna move through the medium like this, because they'll both be decelerating at the same rate, because they'll both be released at the exact same time. So you have to release them at the exact same time, and that's how you won't get the displacement of the steel ball through the medium. Again, in this case, it did appear to still move through the medium in free fall because it started to decelerate first. So it has a faster deceleration rate than the entire container. But you can see that that deceleration rate is actually slowing down. You know, it doesn't increase. So this shows that there is an upwards motion, and not only that, it shows the upward the deceleration in that upwards motion, because the matter stays in that same orientation. In other words, it doesn't invert. And that's what would happen if we were actually accelerating down. Now let me show that. So when we actually accelerate down, we'll show this one. Where's this one? Okay, yeah, again, when we actually accelerate down, again, the steel ball appears to move up. And the air bubble, again, we see that inversion. The air bubble gets pushed down. Not only that, you can see that the flat part switches to the top now. The flat part goes to the top and it shows that it's being pushed down now. So we can literally see the inversion of the air bubble, the push get inverted down now. You know, and again, that motion, that force down is what gives us or inverts density and buoyancy. So again, if there was an actual acceleration down like there is here in free fall, we would see this displacement. Again, the steel ball moving in the opposite, or appearing to move in the opposite direction of the air bubble. Again, that separation of matter, you know, relative to the direction of the acceleration. This is what actual acceleration looks like in free fall. So again, the air bubble being pushed down, again, showing the flat side on the top now being pushed down. When connected to the earth, again, the flat side's in the bottom. So again, the steel ball also shows the displacement of the downwards acceleration by appearing to move up, you know. So, alrighty, so that's that one. Let me see if
he never confirmed if that was the video.
I'm gonna assume it was. Yeah,
We
it
don't
was.
have any.
No, yeah, that's the one. It was. I'm pretty sure. Again, that's something that I did catch right away when I filmed it. Because for a second, I thought that everything should stop moving through the medium. Because I did see other free fall tests where people do drop it at the same rate and nothing displaces. So the fact that I seen it displace or appear to displace, obviously through the medium still, did get me thinking. And obviously the reason why is because it is decelerating at a faster rate than the vessel, because it started to decelerate first, you know. But again, you can instantly see that deceleration rate slow down.
Yeah.
Because that water is pushing up again, or it's resisting it too. Again, water is it's a medium too. It's going to resist. But yeah, let me see. I've seen a lot of demos on YouTube and other videos explaining it. I'm honestly too busy with work and raising daughter as a single dad to invest time into creating an experiment. No, yeah, and I completely understand. You know, I actually have 2 kids myself. I work a full-time job, you know, and I literally have to make free time to do these live streams, for example. And obviously, when I go to university, so I know the struggle. I know how it is. You know, it's not easy. You know, it does require a lot of will. You know.
But I will say that some of the experiments that you've done, some of the demos you've done, they're relatively quick.
Yeah.
When you go out, between the time you go out and film and actually taking the effort into doing it, it's relatively, you know.
Yeah.
Don't take up too much time.
Exactly. I'm kind of a perfectionist in some ways, you know, because when I like to do something, especially like experiment a video, when I want to put a video together, you know, I'm very picky about details, literally the slightest detail. Like for example, my accelerometer here. I was kind of pissed when that girl fucked it up last time because again, I wanted to make a permanent accelerometer, which means I wanted to get it perfectly centered, perfectly, so it's perfectly in the center, and make sure it's tight, real good, so it doesn't shift, so I don't have any issues of it coming apart later. So again, when it comes to doing experiments and having little props and stuff like that, I'm kind of picky, so it might take me a little longer to do an experiment or stuff like that because of that. But again, if you're not like that, then these experiments are very easy to replicate. And yeah, but I understand, again, working a 9 to 5 and raising a kid, it's not easy. And to be honest, it's one of the reasons why I'm doing what I'm doing is because I understand not everybody can do it, and if I can find the time and the will to do it and actually understand this and I'm able to explain it in a very simple manner, then why not, right? So
And just made a good point. You don't need to DIY it. You can always buy stuff that are already like that, or
yeah, exactly.
Find something that's already practical to use.
Exactly. It's funny because I was actually looking up accelerometers like online to see what kind of accelerometers come up, and it's literally just the digital ones. And I even put analog accelerometers. I put physical accelerometers. Right? You're trying to get more detail, and you're not gonna find something like this, for example. In my opinion, this is very cool. But at the end of the day, too, even a water bottle with water, a bottle of water with water will always displace as well, just like this buoyant ball, But my presentation, I like to focus on buoyancy a lot because, again, buoyancy is a force, which shows the direction the force is being applied. So having an accelerometer with a buoyant object to me was kind of something that I've been thinking about, So the fact that this came about, and I made this accelerometer kind of random, it was perfect timing. So again, at the end of the day, I like to think everything happens for a reason. So yeah. The opportunity's there, the thought's there, makes sense, why not? Why not go for it, right? So
Also, you have a wife to help you right now.
No, yeah.
Fair, but there are some wives that probably still wouldn't help. So
Right.
not just having a wife means
No,
you get the help either.
No, yeah, again, I understand. I understand that, it's not gonna be easy, maybe,
Oh, yeah.
especially not right now while you're raising your daughter, but maybe sometime in the future, So and watching a video doesn't take as much time and energy as creating an experiment, especially after working all day, cooking, cleaning, and putting away. I agree. No, yeah, that's true. And again, I'm trying to literally do these presentations and simplify them as much as possible, is to cater to people like yourself that don't have the time, but maybe does have enough time to listen to someone like myself speak about it and actually show the physics, and that's why I want to make short videos about questions about the upwards rising earth, because I do have short videos and experiments showing, the demonstrations. So I do like to, narrow things down and make them concise and very easy to understand for people that don't have time right now, so.
Yeah, and just to add, the only reason why people are saying for you to do the demonstrations or do an experiment yourself is just so that you can know firsthand and see the results firsthand, opposed to just, just believing in other people or having to trust that, people are being honest and stuff. These are demonstrations that everyone could do. Was the initial point being made? Obviously everyone's in different paths and in different lives, living a different lifestyle in different situations right now. So obviously not everyone can do these things. But if you wanted to verify it for yourself, they're rather simple.
Yeah. At the end of the day, I understand people are gonna be in different chapters, in life. At the end of the day, we all have our own paths and we're all at different places in our life, I guess you could say. So I get it. Again, the system is only getting worse to top it off. So it's only getting harder to have free time. I myself find myself always chasing rest. Like I'm always trying to just rest, like I never can get enough rest. And even doing these live streams is cutting into that time, which again, it's fine. It's sacrificing some of that because if I'm always just trying to rest and I never make time to do this, and I will never have time to do this, literally, So I gotta sacrifice some time as well, and that's why I'm doing these live streams so late, because that's when my kids are asleep, and during the day when I'm home, I just want to give all my attention to them 100%, or as much, as I can, because, they're not going to be this young forever. And not only that, this is the time they need us the most. This is the time they need adults the most, is when they're growing up. They need someone to look up to and to learn from. So I can't cheat them out of any time during the day. As it is, I kind of do already on my days off when I do activism. But again, that's a small sacrifice that I'm making to try and reach new people. Because if I just did these live streams like right now online, I won't reach as many people or as many real people as I can actually do in the real world, out in the streets. A lot of these accounts that are commenting right now could be fake. It could be stock accounts. It could be bots, So when you go out on the streets and you talk to real people, you're not talking to a bot. You might be talking to like an NPC, as in like somebody that just goes along to get along, but you're not talking to like a stock account at least, or a troll. You have better chances of speaking or getting a more genuine discussion out in public for sure.
Which is why when we do these open panels, we do encourage people to come on and stuff, because we would like to know if who's real people and who's not too. So, I mean, again, people that don't think they're being heard, this is your time. And, I mean, it's easy to be a keyboard warrior and just keep regurgitating your same comment. You comment every video, and, but actually to come on and talk about it and have those beliefs and or what you think to be true challenge and all that, that's obviously the preferred way, and speaks more than a mouthful on your character as well. Instead of just hiding behind a keyboard or a computer, like you're actually putting yourself out there and giving like, hey, I stand by what I'm saying enough to show my face and, have a chat about it.
Yeah. Obviously it shows character,
Yeah, definitely.
So.
And with the way the internet is now and all these fake accounts or bot accounts or whatever you want to call them, like, I think open panel is the next step to start narrowing out which accounts are real or not.
Yeah. That girl shook the hell out of the accelerometer. She wanted $400. I know, we're thinking about like, damn, she was probably doing that out of frustration. At one point I was like, is she literally trying to like sabotage it? Like, is she trying to mess it up somehow? Like,
the way there was no purpose to shake it the way she was shaking.
Yeah, that was kind of bizarre. But yeah.
At one point it was like to see if she could break it.
That's what I'm saying. Like, it tripped me out. Like, and the good thing, it was literally the second to last conversation. If it was the first conversation, it would have ruined
you couldn't have showed the accelerator. The whole video was
because the whole point is the ball has to be floating in the middle of the water. It cannot be pressed against one of the walls, because that's going to create friction. So if the ball's pressed up against the top, then you might be able to accelerate it without push to the front because of the displacement up. So again, it has to be floating in the middle like this. So the fact that she messed it up and it unraveled and went to the top, I couldn't really use it anymore for the challenge. So again, it almost felt like she was trying to sabotage the prop to sabotage the challenge, right? So it did get me bothered, obviously. And I've learned that from now on, they're not allowed to shake it. They're not even allowed to pick it up. I'm just going to tell them, move it from here to here in 1 second. In other words, accelerate it without that happening. That's it. That's the challenge. At the end of the day, I make the rules. I'm the one setting up the challenge. So when people try to come up to me and try to tell me or try to change the rules, that doesn't work. Feel free to come and do your presentation in Visalia whenever you want. You can stay at my place for free if you want. Then I'm not a bot.
That wasn't specific to you.
No, it wasn't specific to you. No, I appreciate the offer though, by the way. Like, in the future, believe it or not, hopefully, this doesn't, this whole low Earth life doesn't go too far long, because I wouldn't want it to. I wouldn't want to be doing this for the rest of my life, if I'm being honest. So I hope people eventually snap out of it, and eventually, but I do see myself before, if I ever do retire from doing this, because again, if I'm being honest, I probably don't see myself doing this for the rest of my life if it goes that far. Probably get burned out eventually. So again, that's where it's a group effort. It's going to take other people, to come on the conversation. If you really want to see a big change in this reality, like a real big change, in other words, exposing the globe earth lie and everybody understanding that gravity as a pulling force doesn't exist, for example, it's going to require a lot of people. It's not just, if it's just me and Dell and maybe a few more other people, doing this, pushing for this, it's not going to go nowhere. It's going to require hundreds, thousands of people with accounts and on the streets, actually, fuck accounts, literally on the streets, pushing for this, going to the universities, all the major universities. Imagine if we had people every day at these major universities. You really think we're not going to make a noise? As it is, I kind of feel like I'm making a noise, and it's just me. It's just me going to these universities. I try to go to the major universities here in SoCal, but even one person can make noise. Imagine thousands.
That other guy that from the last live stream was like, "Oh, I've seen your table before, and I wanted to stop by."
Exactly.
But I never had the chance to not. So people are starting to remember you. So in a different video, someone else was like, "Oh, I heard about somebody doing this around here on campus or something like that."
No, yeah. Like, definitely people are noticing me at the universities. They're curious about the table, and obviously the people that do stop, they know exactly what it's about. And obviously they can't debunk it. They can't debunk reality. Reality is what it is. And again, it just requires some confidence, some understanding in what you're talking about, and a little bit of balls. And just taking this, again, to universities is going to be key. That's where you're going to get, in my opinion, the most conversations, the best conversations at the end of the day, because the average person at the end of the day, most people just don't care.
Even if you're not confident, you've got to start somewhere. I mean, William used to go out and just stand.
Yeah, at a park.
If you just found him now, you see like a whole setup, and he seems so confident, and so but that's not how it started.
No.
We used to walk around, go to like pop-ups, and stand there with a sign, like
walk around the mall,
asking people if they would fancy a chat, So it just starts somewhere, and the more you do it, the more confident you become.
And the more ideas you're going to get.
Yeah, and again, you get the juices flowing, and you start getting more creative.
The gears turning.
So.
The spider webs, finally,
And everything's trial and error. You go out, it didn't go so well. Well, you can learn from that for the next time, or you can make the changes that you need to make so that it does work better for the next time. Because again, that's exactly how it started.
Yeah, trial and error, exactly.
Yeah, I mean, William wasn't always this confident. He became this confident because of all the practice he's had going out there and all that stuff, and knowing that what you're saying is what it is.
Exactly. Understanding reality and having that as your main tool. Understanding physics and having that as your main tool is going to be the best case scenario, I guess.
Yeah, I mean, and understanding doesn't mean that you're ready to articulate it yet. So obviously that also comes in time and practice and talking to people that you feel comfortable talking to. It doesn't have to be strangers off the bat.
Yes. Believe it or not, I actually had a lot of practice speaking to my family, my brother especially, because obviously we work together. Me and my brother, he watches my live streams as well. I don't know if he watches all of them, but if you're listening, what's up? Point being is, me and my brother, even some of my coworkers, I speak to them, and I actually got a lot of practice speaking to friends and family before I actually went out in public. So I didn't just go out in public, completely blindsided, without any experience whatsoever. I did have a lot of experience, again, practice speaking to friends and family, which I'm pretty sure most of you have already too, because how do you stay quiet after finding out something like this, right?
Yeah.
Like, it's impossible to stay quiet. You have to tell someone, right? And then that's when people lose friendships. That's when you know who your true friends really are. If they're willing to end a friendship based on what they think you believe, because at the end of the day, it's not a belief, it's a fact.
Yeah.
The irony is that they believe that.
Yeah.
So if anything, they're the ones acting cult-like. Because now you're refusing the cult teachings, and he, being a cult member, is refusing you now.
Yeah, you're practically demonstrating your claims, and they're calling you crazy because they rather believe the word salad they were fed
by the cult leaders,
by appealing to authority.
Exactly. Exactly. And again, they're willing to defriend you, based, yeah.
Yeah, I mean,
Based on
people
that.
lose relationships. People get divorced. I hear about, so it might seem like it's insignificant, and if it's an insignificant thing to dive into, but it's really not.
Yeah. Again, understanding it's key.
There's a comment. There you go. Oops.
Lower left, right. Yeah, you're clicking the right click.
Okay, yeah.
What up?
Right there, still good.
Yeah. What up with the whole 9.8 meters per second? Is that rate that you're saying we lose momentum? Because you guys say it's a constant rate. So where do we get the 9.8 meters per second? The 9.8 meters per second deceleration is not a constant until you reach terminal velocity. So I did go over that whole explanation in the beginning of the video. So it's kind of long, but once the live is over, you can check it out.
Yeah,
it's like the first 30 minutes.
Good breakdown.
Yeah, it's a pretty good breakdown. I kind of messed up the math a little bit halfway through, but I fixed it. But again, it's all there for anybody to check it out. And my opinion about what the deceleration rate, 9.8 meters deceleration rate is, and how it correlates with terminal velocity. So yeah, you can check that out. I'm totally not trolling, I swear. I just want to know what the discrepancy is. I feel like 9.8 meters is so freaking fast, it doesn't seem real. Yeah, the 9.8 meters per second rate of fall. Obviously, that's fast. That's 21.9 miles per hour in 1 second. So the globe Earth or stationary flat earthers have to claim that an object goes from 0 to 21.9 miles per hour in 1 second. Think about that. 21.9 miles per second and miles per hour in 1 second. That's 32 feet distance traveled in 1 second. That's my table 8 times. My table that I take out, that's 4 feet. That table that I take out is 4 feet. That's putting 8 tables in front of each other in 1 second. That kind of acceleration without displacement is ridiculous. Now, when people try to say, "Oh, how do you explain that fast deceleration rate without displacement?" Huh? Well, I explain that by the fact that the Earth is probably moving at a very fast rate, because the faster something is moving, especially if there's a resistance, the faster something is moving, the more resistance there's going to be. That's a fact. If you deny that, again, I'm not trying to talk shit, but you're an idiot. The more force there is, the more speed there is, the more resistance there's going to be. Now, the more resistance there's going to be, then the faster the deceleration is going to be. And that's why the deceleration rate has to decrease after the first second, because now you're slowing down. Therefore, the resistance is slowing down. Plus, if there's air resistance, air pushing up, also slowing down your deceleration, you're going to decelerate to 0 eventually. And that's what terminal velocity is at the end of the day. So,
I mean, Blown Spokesman, you're free to call in if you want. It's an open panel.
Yeah.
You click the link, it's an open panel.
Yeah, Blown
You mentioned
Spokesman.
that you'd like to, or that you don't get hurt or something. So
Yeah, if you think that your questions get ignored, or that you just get made fun of, or if you think any of those things, you could call in and see, and actually see if that's true, because I don't treat anybody like that unless they're trolling, then I'll call it out if anything. But other than that, if you want to have an honest conversation about this,
even then, you give most people a lot of grace.
Yeah, anyone can join. Click the link, and yeah, you can have a chat about it too. But square through it gets exponentially faster. Oh shit, you already had shown.
It's squared though.
Yeah, but I would say that the squared is made up. The globe Earth has to say that it's squared because they're claiming an acceleration. In my opinion, it's not squared. It can't be, because the deceleration has to be slower the second than it was the first second. So it cannot be squared. Again, the globe Earth requires that equation because they're claiming acceleration down. Exactly. So again, they only measure 9.8 meters per second. I'll give them that. Mm-hmm. That's all they measured in a vacuum. First of all, we don't live in a vacuum. There's going to be air resistance. So that 9.8 meters per second in free fall here on Earth with the atmosphere is not going to be 9.8 meters. It's going to be like 9.2 meters or maybe 9 meters. I don't know. That's why I started with, instead of 21.9 miles per hour, I started with 21 miles an hour. And then I slowed down the deceleration every second after that down to 0, and we reached 120 mile an hour in about 11 to 12 seconds.
Yeah,
Which-
he didn't get to see that whole.
But again, if you go back to it, that's literally what terminal velocity is. It's the air pushing up, stopping the deceleration rate of the free falling object. It's when the difference in speed between the air pushing up and the free falling object becomes great enough to basically stop the deceleration rate. So it's literally the air pushing up, stopping the deceleration rate due to inertia. So it cancels out the deceleration rate due to inertia because the air is strong enough to push up on the object. So that's the equilibrium they talk about. They invert that and try to say that the downwards force of gravity equals the drag force of the air, and it cancels out, and so again, they're just inverting what's actually happening.
That seems to be the case with many of their claims.
Yeah, exactly. So one starts to see that inversion everywhere in many things. Exactly. Again, it's not just with the upwards motion and inverting gravity. Obviously they try to invert the definition of level as well. Instead of horizontal, they try to say it's equal distance from the center to the outer circumference of a sphere. So it's basically a curve without a curve. That's what level means. So it's a constant curve. Equal distance from the center to the outer circumference. So yeah, they just invert everything. At the end of the day, again, the sun and moon obviously appear to be the same size, but they invert that and say that one is way bigger than the other. And again, it's all to feed into their model of a heliocentric world, of worldview, that we live in a vacuum of space balls that are far, far, far away, so again, it's all just stories and inversion to fit their model. That's all we can do. Mm-hmm.
Yeah, they'll never demonstrate their point of downward acceleration.
Yeah, that seems wrong to me too. Well, the deceleration rate being slower the second than the first. The deceleration rate cannot physically be faster the second than the first. That defies physics. If you claim that the acceleration has to increase after the first second, that's again, deceleration is there because of the resistance. The higher the resistance, the faster the deceleration. And the only way to have higher resistance is to be a faster force, or a greater force. So yeah, the deceleration rate of an object can only slow down until it's completely at 0. Literally, that's physics. That's how it works. Again, if anybody thinks that that's wrong, please jump on and present to us, your line of thinking, your reasoning behind that, So, all right, I'll leave it open for another 5 to 10 minutes. See if anybody else joins. If not, we're gonna end up calling it already. So,
Yeah, it's 12:30 in the morning.
Yeah, it's 12:30. So yeah, we'll wait another five minutes or so and see if anybody joins. If not, we're gonna go ahead and call it. So, how did the light get started, and who started it? Believe it or not, that I ponder that question a lot. Which is funny because I'm pretty sure most of you know that I've taken shrooms before, obviously. And in one of my experiences, under the influence, obviously I took some shrooms or whatever, I got into deep thought about that, about like who's behind all this, like why would you do this to your own kind, me and her, we were talking about, we're tripping out on it, like how did a evil come to be, right? Like, in other words, like why take advantage of others, right? And at the end of the day, it's like, it can either be two ways, because even if the economy started as a good thing, right? Because that could be another thing, like, society started and then little by little started getting corrupt, that could be a possibility. But
I feel like hard drugs have, somewhat.
That's another conclusion we came to. Is like maybe somebody took some hard drugs and completely got desensitized, and maybe it was a group. Eventually, that guy was in that same mentality, and maybe they started putting their mind in the wrong things because it had this mentality now, or again, it could be somebody that was raised just, without any love, without any care, and they just
there
grow
are
up
people
hating.
that are raised without morality,
Exactly,
raised not to show emotion, so they don't know how, or to feel emotion,
or even express it. Obviously,
so they can't express it. They can't, so in a way, you can groom people to be brought up that way.
Yeah. So yeah, at the end of the day, how it all came to be and who started it is a mystery. You could only ponder. But here's my thing. Here's where I was going with. In my trip, I was trying to figure out I was like, I even broke down. I'm not even gonna lie. I even broke down crying because it's just sad, that you fellow humans that we trust are doing this to us. At the end of the day, doing this to children, completely altering our perspective, completely taking advantage of us. All of this. Point being is that I made a promise to myself, literally, that I was gonna expose this lie. And this was before I started doing activism, which is a trip. It was like a couple of years before I started doing activism. It's like that's how passionate I was, about this. That even though I can never figure out who is behind this and who started it and how it got this bad, even though I can't do that, what I can do is expose it. So then and there, I knew that I was going to expose this, that my will was going to be to expose this lie. I made a promise to myself. And I feel like I'm carrying out that promise, because ever since then, it's just crazy, how I started doing activism and how it's gotten to where I'm at now, the presentation, the articulation, everything, to my slides, everything that I show, it's I can't even explain how it all came together. It's a trip. It's just literally a lot of thinking, a lot of pondering, a lot of talking to myself at the end of the day, and again, just being fueled by the fact that we are being fucked. And there are people behind this, pushing this, benefiting from all of this, while the majority are being fucked. So I completely see that, and literally, just it's literally what fuels me, to
imagine having this is exactly what's happening and how fucked it is. Imagine having kids and raising them in a room, never allowing them to leave the room. They can only examine the boundaries you set, and you're just keeping they're living their life in that room, and they think that's normal, and you're just keeping them happy, giving them shiny stuff to play with and keep them distracted, and there's a whole world out there besides what's in this room or this house, or and it's so fucked that most people die never getting to experience it, to know what the dimensions of the whole place of the house is, not just the room. You just shove them into this area and keep distracting them, and it's completely fucked.
Yeah, and they start asking questions about the room, and instead of you showing them answer, you just distract them, right? It's kind of like that. And I imagine someone doing that to kids, inside of a house.
Well, I mean, that's what they do here.
And that's exactly
what I'm saying.
Yeah, on a bigger scale.
Yeah, you get senators for doing things, and it's crazy. They're just keeping you distracted, and it's like, look, now there's this basketball championship, the finals going on, and now look, there's this sport now. Now look, there's political drama. Now look, and then you're just so distracted, and now you got to go to work, and now you got to. And whatever time you have left, you got to spend it with your kids. And, you're never really living.
Right.
You're alive and in bot mode, robot mode.
Like your heart's pumping, but there's nobody there in a way. You're kind of like on autopilot. Most people, again, when you get into a routine, I've noticed, because again, from experience, if you get into a routine, hardcore, you're basically on autopilot. You get to autopilot at one point, and it's like
you're not even man anymore. You're just machine.
In a way,
you just wake up at a certain time every day, clock out at a certain time every day. Everyone's going home and stuck in traffic at the same time every day, because everyone's basically living the same life, this robotic life on a time schedule. And it's
again, the calendar that we have, the 24-hour clock that we have, is literally just there for the slaves. It's literally just there to keep
Get
all the
back to work.
slaves, to keep all the slaves in line.
Yeah.
Literally. The 24-hour clock we use and the fucking calendar we use is literally there to keep the slaves in line, you know. And again, school is part of that grooming of getting people used to a schedule, getting people used to a routine, you know. And again, when you become an adult and get a job, and you're already used to routines and just doing what you're told, you know.
You're just picking up where you left off.
In other words,
you're replacing school with work.
So I'm not surprised that people grow up not developing their mind and having this childlike mentality of being so gullible and so easily fooled.
Just in general,
Yeah.
and then you find them at 27 and they're still childlike. They didn't mature. They didn't do any mental growth of any sort, and they're supposed to be making decisions for
Exactly.
other people and for themselves and for us. Like, what kind of decisions can you make if your mind never even developed?
Exactly. So do you really have free will? You know, at the end of the day.
I mean, you have free will within the choices we give you.
Exactly. Like if your mind didn't fully develop, though, could you have free will? I don't think so.
Yeah.
Because I think free will comes from having a full understanding of
Well, if
what's
your mind
being presented.
didn't develop, I would say then you're childlike. And can children make their own decisions?
Exactly.
Yeah.
So yeah, again, it goes back to the basics.
Mhm.
You know, again, developing the mind comes with understanding your own mind, which again comes with trusting your own common sense, having your own discernment, you know, and not just believing people. Again, at the end of the day, just believing people is what leads to mind control, because that's what it is. You know, mind control is people believing lies. And now they're able to manipulate you because you believe these lies. So again, jumping into ideas and jumping into beliefs about our objective world is the worst thing you could do. It's the worst thing you could do. Again, if you don't understand something, it's fine. Just remain there.
Yeah.
Remain not understanding it.
It's okay to say you don't know
Exactly.
or you don't get it.
Exactly.
It's not taboo. That's honest and respectable.
So again, believing, even then, if you don't understand the motion of the earth, don't believe it. Don't claim it. Don't believe it. If you don't understand it, my best advice is,
it's fine. Just leave it as
like,
it and just keep trying to look into it. Keep trying to, see if someone can word it in a way that you'd understand. Again, that's why it's important for more people to be doing stuff like this, because everyone articulates things differently.
Exactly. So, see if there's anything else.
If you like psilocybin, you might like DMT, amazing stuff.
Okay, so sending my DMT, amazing stuff. No, yeah, I've heard of DMT and stuff, and I am open to trying it for sure. Obviously, it's not that easily accessible, but I'm definitely, it's something in my bucket list, right? To try DMT maybe one day, but it's not a priority to me though. But it will be something that I would try. All right.
Well, I don't see mushrooms as a drug. I see it as the same as weed. It's a plant. It grows like that, unmanipulated.
Oh yeah, so here it is. Oh, I don't do drugs at all. I never will. Okay, well, So a lot of people think that marijuana or psilocybin or
psilocybin's the correct, I guess, the fancy term, but it's just mushrooms.
Yeah. So a lot of people think that these are drugs because they can alter your consciousness, right, or whatever. Here's the thing, though. My definition of a drug would be something that's man-made. It has to be man-made. That's my definition of a drug. And something that's detrimental to your health and can lead to death. So those things are the things that, in my opinion, would define what a drug is. So all the pharmaceutical medicine, right, all the drugs from the pharmaceutical companies, they're drugs.
Mm-hmm.
Why? Because they're man-made and they're detrimental to your health and can kill you.
Yes.
So when we're talking about, in my opinion, beer could even be considered a drug.
Yeah.
Why? Because it's man-made and it's detrimental to your health and it can kill you.
Mm.
Now, when we're talking about marijuana, mushrooms,
no one's ever died from
ayahuasca,
mushrooms.
it's not man-made. So there's no chemicals in it. no man-made shit in it. And it's not detrimental to your health. It's the opposite. It actually helps clear up your mind. It actually helps you putting you in the moment and analyze
Mushrooms
your reality.
Can beat depression. Mushrooms can make
Exactly.
people that were on the verge of suicide find a will to live. These are all things that they've done.
There are a lot of tests, and yeah, they do show that they do.
And no one's ever died from a mushroom overdose.
Or smoking too much weed, for example.
I mean, I've had a near-death experience with mushrooms, but obviously I didn't die.
Again,
or a near-death, right? Yeah.
Exactly. So again, that's just a simple definition that I have to basically separate the two. In other words, natural plants, in other words, natural enhancers, you could call them.
Mm-hmm.
They're not drugs, in my opinion. They're plants. That's what they are. They're plants. If you want to categorize,
like that.
They just grow like that, exactly. So if we want to categorize it even more, obviously, I would say they're plants, and then obviously weed is a flower.
And to give you a difference, sure, cocaine comes from the coca leaf, right? But
it's
it undergoes so much manipulation to become the drug that people use.
So in other words, it's man-made at the end of the day.
It came from it has to do with something that is natural, that's a plant, but obviously it went through man manipulation and processing to become what it is. A lot of chemicals too.
Yes, so heroin, cocaine, all of these are drugs, 100%. And,
besides what the hospitals offer.
Yeah, at the end of the day, you can overdose, you can die from using these again, and yeah. So again, that's my simple definition. When people like to say that smoking weed or mushrooms are a drug, again, I would like to hear their definition of what a drug is. Well, what is a drug to you, right? So that's just my definition, again, at the end of the day. And yeah, I don't consider mushrooms or weed drugs. They're just plants. They're natural enhancers.
It just grows like that.
Exactly.
Again, they're not just, people probably think that psychedelics or stuff just offer, party or whatever. Like I don't think it's related to that at all. Again, they teach you a lot.
Marijuana makes me really paranoid. Is that normal? I mean, it's probably normal the first couple of times you try it. If it's your first time trying it, or maybe your first few times, that is pretty normal. But if I guess you maybe just need to take smaller doses, and ease yourself into it, because you do build a tolerance to it. And once you build a kind of like a tolerance to it, you don't get paranoid anymore. And what happens is you just start to feel chill. There's a reason why it's called stress, here out in the streets. It's like one of the street words. It's because it relieves stress. Not only that, it relieves pain too. So it's a really good medicine for people that have trouble sleeping, have trouble relaxing, have body pain, have mental fog. All of these things is really good for. If you could get past the paranoia part, again, maybe you need to adjust the dose.
Maybe
you need to smoke less or take less.
The strain. I don't know if you're smoking
Different
indica, sativa.
Yes.
There's a body high, there's a head high, there's,
You probably smoked a really strong OG, a really strong indica, so you probably need a hybrid or even a sativa.
And if it's from like a shop, I don't really trust,
shops are really iffy nowadays.
We're growing our own, legally and stuff, so.
Yeah.
Sugar. Okay, this is a fact. Sugar is probably worse than most drugs.
Yeah.
If you quit sugar from every source for like a month, I mean, you'll see that even before the month is over, you'll have physical withdrawals. There are people that get the shakes and headaches and all that stuff from just cutting out sugar from their lifestyle.
I mean, just cutting off coffee does that, and I think it's because of the sugar.
Well, yeah. I mean,
it's probably not even the coffee as much; it's mostly the sugar where people feel the withdrawals. So, cool. All right. So it's almost gonna be 1 a.m. here, so we're gonna go ahead and call it. Again, the presentation about terminal velocity, it was my first time ever doing it. It was a little rough, but I feel like I got my point across. If anybody disagrees with the presentation, Please leave your comments. You know, I do want to hear your opinion.
Feedback.
Exactly. I want to hear, you know, the feedback. I want to hear if you disagree with it. I want to hear if you agree with it. You know, I think that can only, you know, progress the conversation. You know, that is one of the main questions a lot of trolls ask. Well, how do you explain terminal velocity, right? So I know it's something that came to me and I just felt like I needed to share it. So again, it's not going to be the first or last time that I do that presentation. I am going to make a short video of it, 3 to 5 minutes, hopefully. And yeah, and that's going to be it for this one. Do you have anything you want to say before we go? See if there's anything here.
If we didn't catch you, to say hi. I mean, take care of everybody.
Yeah, I guess that's going to be it. So yeah, we'll see you guys on the next one. And yeah, you guys have a good night.
Day, night, afternoon.
Wherever you guys are at. Have a good rest of your day or night.
There you go.
All right, peace.
Take care.